Hey everybody, welcome to day 2 of ObservabilityCon. I'm excited to be hosting a panel today with a few fine folks from our industry, so let me introduce our panelists. First, I'm going to introduce Crystal Hirschhorn, who is currently the Director of Engineering for the Infra, SRE, Cloud Platforms, and Developer Experience teams at what I call unicorn startup Sneak. Crystal has over 20 years of experience in the industry, spending most of her career in media, technology, and publishing. She's worked for companies like Condé Nast, BBC News, and the National Archives. Welcome to the panel, Crystal.
Hi, thank you for having me.
Yeah, we're glad you're here. Our next panelist is Nathan Berkeley, who is currently a principal software engineer for TripAdvisor. I'm sure many of you have used or heard of that service, where he SREs in real life. He's held development positions at Shiloh Tech and 3E Software and been in the monitoring and observability space for almost a decade. Welcome to the panel, Nathan.
Thanks for having me.
Yeah, we're glad to have you here. And last but not least, I'd like to introduce Mike Johnson, goes by MJ, who is currently the global head of support engineering and trade and treasury payment services for Citi. He's held engineering leadership positions at companies like Highcastle and Broadridge, and has spent time as an award-winning developer and founder of at least one company that I know of. While currently in the financial services sector of our industry, he's also worked in cyber and way back in the day, even worked with a BBS turned service provider. So welcome to the panel, MJ.
Thanks. Excited to be here.
Yeah, we're excited to have you. So let's kick it off. I wanted to start the conversation by talking about your Grafana adoption story. So Crystal, since I started with you, let's start with you. Can you tell us a little bit about kind of how you came to discover Grafana, why you decided to adopt it, and what that journey's looked like so far? And then we'll go around the horn.
Yeah, sure. So I've been at Sneak just more than a year. When I started there, I started with a really tiny team of just 2 engineers and 1 engineer on loan. And when I started, despite themselves being called SRE, I found that they were operating more like an ops team. So in a highly reactive mode, supporting about 150 developers already, just 3 people.
Okay.
So you can imagine what that was like.
A lot of work.
Yeah, exactly. And I just found as well, like observing, that's what you do when you start somewhere. And after about week 5, 6, I just thought, gosh, Prometheus seems to be going down all the time. And this is really painful. And also, it's not our USP as a company. And, I'm a big fan of buy versus build,
okay.
Where you can get away with that. And so I just said to the couple of engineers that I had, like, we really need to rethink our strategy here and look for something externally hosted, essentially, that's a lot more stable, and that's your USP.
Yeah. So you love the tech, but maybe we're better at hosting it potentially.
Exactly. Yeah. And I think like what I've found as well is that it's kind of gone from strength to strength because you've added more products to the platform, the portfolio of offerings. And I think like eventually that's where a lot of companies want to go as well. It's like an observability platform, not buying tools from multiple vendors if they can help it.
Yeah.
So we started off using Prometheus and Grafana, and we recently started experimenting with Tempo. And actually, that wasn't kicked off by my team. That was another team internally that did that, which was really interesting. So it's kind of like organically, other teams trying out tracing and wanting to push that forward a bit faster. So yeah, that was really cool.
Right on. The power of open source.
Exactly.
Yeah. Right on. Thanks, Crystal. Nathan, can you tell us a little bit about how you came to Grafana and what your adoption story looked like?
Yeah, so I guess ours starts 7 years ago or so, when we were still doing everything with Cacti and SNMP, if anyone used those. We finally decided to get off of that and get something a little bit more friendly to application monitoring and not requiring us to run SNMP everywhere, and adopted Graphite, and then quickly ran into the high cost of producing reusable dashboards in that, and the lack of interactive graphs, and like basically needed a better front end. And so we started playing with the, at the time, relatively new Grafana. And then since that got introduced to the stack, it's become a increasingly central part as we use it to tie in more data sources instead of just using it as a Graphite front end, and adopted more of that stack. At this point, we primarily use Prometheus over Graphite. And also, like, we're now experimenting with tying in Tempo and Loki initially through the cloud-hosted stuff,
Okay.
which we're kind of tying to a push into cloud adoption. We've traditionally been mostly on premises, and then as we're pushing teams out to the cloud, we're kind of trying to modernize our stack and also get out of the business of running some of this ourselves. That's how we started interacting with Grafana Cloud specifically, was to support some of those first adopters for our move to AWS.
Yep, that makes sense. Right on. Yeah, I know TripAdvisor has traditionally, made these hard decisions about build versus buy, and it's, changing over time as it does typically. So it's good to hear.
Yep.
MJ, can you tell us a little bit about? Oh, go ahead, Nathan. Sorry.
I was gonna say, yeah, we still have some transitioning to go there, but the direction has definitely changed a lot in the last few years.
Yeah, right on. MJ, tell us a little bit about your Grafana adoption story at City and maybe even before.
Yeah, sure. At City, we're kind of on the cusp of, moving a lot of our services right now into the cloud. And so most of our stack is actually a legacy one. So we're kind of architected in verticals. Each application team kind of looks over, their little piece of the world, but from the support organization, we need to look at the business process end to end. So what we've really done is we have lots of niche tools which support various different technologies. WebSphere.net, you can imagine all we got in the bank. And what we're really using Grafana for is to flow all of that data into that so that we can see that end-to-end business flow, in one single spot. And then we'd like to do more advanced things as the product develops with it, to do like machine learning. And I know one of the topics we'll touch on later, AI ops, so we're very interested in a lot of that once we have that all together.
Yeah. Well, I think we'll definitely get to that today for sure. It's the more future looking stuff. Since all of you are using Grafana and, Prometheus or Graphite is a big part of that story, but Grafana is so much more than that, right? I think we all get that. How much of the big tent strategy resonates with you versus having to bring all your data to one vendor to get a view and get correlation and have that kind of penultimate experience, I guess, with observability? Like, how do you decide when to adopt all things from one vendor versus keeping some things with one and another thing with another? Does that make sense?
Yeah, I know that's one thing where our opinion on it has changed a lot over the years since we initially adopted this. Like I said, initially we just had everything go to Graphite, and that was, the one true source for data. But as the number of things contributing to that ecosystem and the different types of stacks we run, especially as we've moved from a on-prem monolith to a microservice architecture to starting to move to the cloud, the number of data sources that make sense to monitor those things with has gone up. And rather than fight to get to set up integrations with each of those things into one repository, it's been a lot easier to just be like, okay, we'll just add that data source to Grafana and let the data live where it wants to live. Especially when we move to AWS, it becomes like so many things have native CloudWatch integrations, for instance, where it's like we could spend the effort to get that all out into Prometheus, or we could just save the time and only pay to store it once and just leave it where it is and get it in Grafana, and that's been super helpful. Also, data source or database data sources are huge because they let you query production data from your monitoring system.
I wonder
in the rare case where you really need that.
Yeah. I wonder eventually if that will start to collapse some of the ETL processes we're all familiar with. I think it already has in some cases.
Yeah, I was going to say, I think we're following a very, similar approach. A lot of these tools, especially we've been investing in them for years. There's a lot of cost to move away from them. So, we've been looking to send a lot of that data as well, similar to Nathan.
Yeah. Rip and replace is never easy, and it's fraught with peril usually. So I love the idea of, as a leader myself, I love the idea of buying time for myself, right? Like I can now, if I adopt Grafana, I can start to get a little more strategic and pick and choose when and if I decide to replace a backend technology. And then my hope, of course, with Grafana and our users and our community is that you experience less disruption in the user experience as you decide to do that, because you're unifying the user experience. Crystal, what about you? Like when you think about Loki, Tempo, how does that influence your decision making as you start to look at the future of your org and how you're going to monitor everything?
Well, so from my previous time at my last company, Condé Nast, we didn't use Grafana and Prometheus there, we were actually using Datadog.
Okay.
I found a lot of value though, because I was overseeing that engineering org and just having the one platform actually.
Yeah.
And I think like you have to kind of prioritize your use cases probably and say like, what is an absolute must for the tool or platform that I want to buy? And what can we kind of forgo? It's always trade-offs, right? So I think like that. I think less vendors means less integrations, means less complexity, means less ops, and it pays massive dividends for like the general product engineer, who maybe is not so infra opsy background. And I think like if you can get a long way with that, I feel like it can level up your engineering org. I do think like one of the things we talked about previously was like the kind of barriers that can be put in place, and how something that's seemingly small can actually have a huge impact. So that's why I think like sometimes single platforms are better if you can manage with that. And so for us, like we are using a different vendor for logs at the minute, but yes, we're definitely thinking about the potential of moving to Loki. And some teams have already, again, like a bit like Tempo, some teams internally have already started experimenting with Loki. So it's been good.
Yeah, that's good.
Yeah. Allowing that experimentation is always the interesting thing, right? Because that's how we end up with so many systems that end up getting pulled into this. Is someone goes and tries a thing over here, and someone else goes and tries a different thing over there, and then you have to figure out how to get them all back into one system, and that's where Grafana has let us be a little bit more permissive, because we can still end up with the same front end so that engineers don't necessarily have to care, but it's a real struggle from the ops side to keep that contained to something that someone knows how to manage at least.
I think like for us, like the idea is to kind of create the paved road or paved path, as people say, and that stepping off the paved road is fine, but it comes with some constraints and, consequences, i.e. you manage it in that team. And that means operationally as well. So the burden is felt there because frankly, my infra org is never going to be big enough to do all of that. But it's the right kind of incentive structure as well. Like I had an old manager that kind of changed my mind completely about this concept. He called free market software, which is like software is on the free market. Most software nowadays is open source. You have to create something so good that people want to adopt it. And I think that's the right way to think about it, right? About what we do is like providing a service internally that is so good that the devs, like, why would they look anywhere else? But the experimentation is still there. Like, I think that's a healthy thing, like to allow teams to go off the path they want to, if they think it's helpful.
I think paved roads helps a lot with that as well, right? It gives them kind of some parameters to work within, and they can still keep their creativity, within reason.
Yep. Yeah, I've talked to a number of leaders over the years, and that's one of the things they're always trying to balance is like control versus free reign and innovation. And there's whenever you talk to a CISO, the word risk always comes up too. It's like, how do I manage the organization's risk without stifling innovation? It's a really hard problem to solve. And I think it's one of the beauties of Grafana's approach in the market is that if you want to go big tent and use all these different vendors, and in some cases you don't have a choice, then you can do that. But if you also want to, have your cake and eat it too, you can unify on one vendor. And, I keep looking at things like our plugins, right? When I first started at this company, we had under 200. Now we have 220 plus, and it keeps growing. So, when I think about big tent, I also think about the time horizons of big tent, because sure, it's fun to talk about all the technologies that exist today and how much coverage, but there's also how far back in the past do you want to go? Like, would you put Grafana in front of your mainframes, and does that make sense? And, in the future, who knows what's going to come next, right? It's going to be more abstractions, I'm sure. So another thing I wanted to ask you about is when you think about the Grafana approach specifically with this big tent, does it change how you think about team organization? Like, has it led to changing how you organize the teams? Do you think it will lead to how you change how you organize teams?
I mean, in our situation, I wouldn't say it's changed our team construct, but it definitely has changed how the teams are working within each other. again, before we would have kind of these verticals of like application diagrams and stuff like that, and now it's more horizontal about the flow of the application itself. And then folks are thinking about, what they have to look at upstream and downstream. It's been an interesting transition, to see a lot of these teams work across from each other.
MJ, you think that's similar to how we went from, well, back in my early engineering career, TDD was not a thing, but eventually test-driven development became a thing, which thank goodness for all of us. Do you think there will be a time and a place, if we're not already there, where it becomes also observability-driven development, where you think about observability from the moment go, the moment you start?
Yeah, I mean, I certainly do. I think we're kind of on the front door of that right now. We're getting a lot of the monitoring and the metrics in place, as part of our CI pipelines, right? So we get that stuff in non-prod, which, for an enterprise, it's been a little bit of a challenge to get even that far. But I think the journey is there to make it all the way to observability end to end.
Yeah, I mean, I think it'll end up being a little bit different than test-driven development, just because, like, you want it to be a first-class citizen. You want it to be something that people are thinking of right off the bat. But if you think about, like, treating it in the same way you treat test-driven development, where it's like write the tests first and then write code to the tests, the case where you start doing that with monitoring is just test-driven development, right?
Yeah.
Like, you start using your metrics as input to your tests, but, like, it's an input to that, not a new thing.
Yep, I think that's fair. And I also think, like, when you look at platform as a service and things like that, as those evolves, like with the 12-factor apps concepts, whether you believe in it or not, one of the factors is logging, right? Like, that's a core part of a PaaS. And so if you log to the nozzle or whatever they call it in Cloud Foundry, for example, then it's just part of what you get is adopting that platform. I think that's important.
I know for us as well, like one way that I tried to change this behavior before was writing out some production readiness standards, but putting those in front of teams as they develop, rather than it being a gate that comes at the end that they have to jump over, right? Or tick all the boxes. I know a lot of SRE can take different forms. Like sometimes it can be like, yes, tick all these boxes so we can run your service for you in production. I've never had that model of SRE before, and I don't intend to at Sneak either. So I do quite like having production readiness standards as something that kind of reinforces, like, hey, your software, when it's running, you need to really think about what that looks like early in the process. And I think that's how you can start to treat things like observability more like a first-class citizen as you develop. But also you could put anything in there, right? Like security is another thing that's really close to me and my company, obviously.
Yeah.
So.
Yeah, we've had a similar approach to that too, though ours tend to be a little bit more centralized because we've historically had more centralized ops. We're trying to get away from that at this point, but like the same, just like, hey, these are the types of things you should be looking out for while you write your code before you come say, let's put this in production. Makes it a lot easier for both sides, for sure.
Just curious to the both of you, like, are you implementing that manually, or is that a CI and like integration point you have? How have you gone about solving that?
Depends.
A little bit of A, a little bit of B. Some things are programmatically tested where they're like, hey, do you like support health checks, stuff like that? That gets tied into CI pretty easily. Some of it's tied into the build system for the like common path apps. You can divert from this and those things wouldn't get caught by these tests. But like if you're building what a typical microservice for us looks like, it'll sanity check a lot of stuff for you. And then part of it is just part of our review process for like taking a new project to production. These are the questions people will ask you. These are the things we teach engineers to think about, and it's a culture thing.
For me, it's more, I think it depends on how much time you have. So like my teams are quite new, but at my last company, we definitely got to a point where we automated a lot of it. Yeah. So I think it's just a process that we have to go through over time. But I think a lot of it can be automated, actually. But I would agree with Nathan that it's probably not 100% automatable or desirable potentially to do that either.
Yeah, I agree. I think we're in the same situation. Yeah.
It's easy to check that people did something that claims it did all the things, but it's not easy to make sure that those are reasonable implementations. Like a health check can just be a no-op, but it'll pass along
Yeah.
CI, right? So like you still have to have the culture to do the right thing. And like, what does a good health check look like?
And that's super important. The definition of good needs to be shared for sure. Yeah. Well, I think we can't talk about all the things we're talking about right now without talking about industry standards, and things like open telemetry come to mind. So I'm curious to get your take on open telemetry. I know that when we were preparing for this, Crystal and I were joking that another standard to consolidate standards just ends up creating yet another standard. So Crystal, maybe you could start by talking about your thoughts on OTel and whether or not you think it's a good thing, and if so, like how do you see it changing the way you work, if at all, over the next few years?
I actually quite like industry standards for things. And I think that open telemetry has a lot of potential and actually quite a lot of adoption at this point as well.
Yeah.
Like we used Jaeger quite heavily in my last company with Tempo. I mean, it's kind of a similar deal there. So I think that, and I just love things that come from a community, right? Like an open source community, that there is a community around that developing it, and taking, lots of developers working on it, taking different use cases, making sure that that's actually built into the standard itself. And I kind of feel like we do this anyway inside our own companies. Like right now, my team is talking about, well, what does our logging standards look like? What will our tracing standards look like? What will our metric standards? Should we build libraries around these things to give teams guardrails? I mean, it's stuff, again, like I had done at my last company, but again, having quite new teams and all of this stuff being fairly organic for the last few years, it's come back around like as a topic, and it's like, yes, we should probably do these things. Another standard I'm quite interested in, and my team has started looking at, is the Open SLO standard. That's started to get a little bit more traction, and we're thinking we will likely adopt that standard, but it's a bit early for us. But we think in the next few months, when we get to a point where we actually have SLOs, that this is a standard we'd like to adopt as well.
Yeah, that's interesting. Nathan, go ahead. Your thoughts on OTel?
Sorry, who?
Nathan, go ahead.
Yeah, the open telemetry stuff for us has been kind of a mixed bag in that we don't necessarily write everything to open telemetry standard itself, but the thing that's been extremely valuable for us that's come out of open telemetry is the glue code, for lack of a better word. Specifically in our tracing pipeline, where historically we use the Zipkin headers for trace propagation between our services, but it's really easy to use the OpenTelemetry collector to input various standards and then output something that whatever you need to talk to can talk to. And that's been great for integrating with Tempo, which we were previously integrating with Jaeger and previously integrating with Zipkin. And just moving through those has been extremely painless because there's this piece of really great glue code that came out of the OpenTelemetry project. And that kind of technology is super useful for making your stack technology agnostic as people introduce more things that just okay, we introduce something that really wants to speak Zipkin headers or really wants to speak OpenTelemetry's protocols or whatever. It'll all go into the same place, and then we can treat it the same downstream, which makes a lot less stuff that we have to maintain.
Yep. MJ, what do you think about it?
Yeah, I mean, I'm personally a fan. I like the concepts that it's bringing to future proofing. I think in the enterprise, again, we're running a lot of legacy stacks. So, to be able to actually implement it with a lot of that has been a little bit of a challenge. So I would say probably for the future of our roadmap of technology, I think it's going to be in consideration. But until then, we're looking at other solutions to bring everything together, like we touched on before.
Do you think things like the OpenTelemetry schema will drive more adoption of technologies like Grafana, or do you think that it's going to be really hard to get the industry to agree on a single schema for OTel? That's one of the things I've been wondering about is it's tricky to get everyone to agree on this stuff. And especially when you have a bunch of different vendors all competing for the same business, they may not necessarily want to agree just for, reasons of what's in their best interest, for example.
I think it'll
be. Yeah, I mean, I think it's going to be a challenge. I mean, I look at what happened with bytecode instrumentation, right? And, you have many different players, trying to come up with their own, standards to win the battle. So I think it'll be a challenge, and you're just going to have to pick one and go with it at some point.
If anything, I think the lack of a standard there is why Grafana is so useful, right? Because it's the thing that sits at the top of the stack that meets the data where it is, right? Like, if we actually had a consistent schema, you wouldn't need a tool like that quite as much, because everything would be in a consistent place and you wouldn't need something to glue it all together. But we don't, and we're not going to have that for a long time. So having something that can go to the data where it is makes that a lot less critical.
Yeah, I'm excited about it just because I think it does make our job easier too, right? Like the community's job and Grafana's job of keeping our tool maintained and up to date and innovative. Like we can offload some of this decision work to the community, right?
Mhm.
And then once we implement it, it makes it easier for us and then our customers and community to onboard new data sources. Things should just work. And then maybe this is a good segue into something like automation and ML AI. We all know Gartner's been talking about AI ops for a while. And I think there's a lot of orchestration that we've already done with infrastructure as code. And given that everything's API first now, like how do you see this evolving over the next few years when we have ML technologies that could potentially warn you of anomalies that it detects and things like that, but it's still up to the user to really determine context and things like that? I'm curious to hear your thoughts. Crystal, maybe we'll start with you.
Yes. So I am going to be pretty transparent that I'm a big advocate for human factors and system safety kind of fields. And so I don't think that humans can ever truly be written out of the equation, that they will always provide a valuable role in kind of dealing with incidents, near misses, whatever they might be.
Yeah.
And I think that we sometimes maybe underplay just the amount of context and capability our brains can achieve at rapid speed. Just like, the kind of like weird signals or interpreting data or, just things that we kind of just know when we're dealing with an incident. So I don't think we'll ever be written out of it. I'm interested to see where it goes, though, in terms of a field like AI ML. I think ML seems interesting from the point of view that it could potentially learn from us, from humans, and replay some of that. And I think in some cases we could write the playbook, and that's something that we're looking at actually in my team right now, something called BlinkOps. Like, is there really a technology there that could at least help us to some degree, like with the 3 a.m. wake ups, like the kind of like, oh, maybe we could do something like switching a feature flag or something like a bit more common like that, where we might be able to mitigate the problem at least for a few hours. But yeah, I still have hesitancy to say that we're going to get there in the next couple of years. I think it's going to take maybe another 5 to 10 years truly to get there, if we ever do. I have, again, pretty strong opinion that I think it can only get us so far, because I also would worry that we would over use AI and ML, and that I think, as we said before when we were talking before, is like, it's like you do things in incidents and then it has like quite different consequences. You're like, damn, I didn't expect that to happen, and then like suddenly you're in a lot more trouble. So I think like handing that off to a machine, I don't know, like maybe I'm just a little bit skeptical of doing that just yet. So.
Yeah, I think we share similar opinions here. Like the thing I think it's going to be useful for, and it's starting to get there, but we're not quite there, is for like detecting related changes when you have an incident. Hey, the service went down. What all changed? What endpoint suddenly started getting called more often at the same time that happened? Like identifying that kind of thing can be very useful, especially when you've got thousands of endpoints and visually scanning through 1,000 lines superimposed on each other is really not legible. And like figuring out how to present that data can be very hard. And using ML to identify the things that you probably want to look at could be very useful. For like automated resolution, yeah, we've got a ways to go. When we do experiments with like using auto scaling and stuff, it solves 80 to 90% of the problems, but then 10% of the time it makes some bonkers decision and you suddenly need a human where you wouldn't have before because it scaled something down that it shouldn't have, or scaled something up and now you don't have room to schedule things that you need to schedule, or pick your failure mode. Machines will find a way to break it.
Yep.
And some of that's going to come down to building apps that respond better to the types of resolutions that ML-based auto resolution will try, much like we've moved away from highly stateful applications because they deal better with, among many other reasons, but they deal better with like orchestrated container environments.
Yep.
Maybe we'll see a change to apps that deal better with the types of solutions that we can generate good automated resolution for. Maybe we won't. It'll depend what the standards look like and how well that meshes with the rest of the industry. But there's at least some room for it there. Timetable, at least a few years out.
Yeah, I think the intention and the context are going to be really hard for us to encapsulate in code, because like the code doesn't know who, or like Grafana doesn't know who is exactly looking at it right now and what they're trying to find, and they don't have all the, as far as I know, we don't have a really good industry standard way to take all of the context and knowledge out of a developer's head about how a system runs and put it into metadata that then a model can use to make decisions. And even if we did, that's going to come with bias. And then you run the risk of getting things overfitted and all that stuff. So all these fun ML terms I've been learning over the last few years, like they actually do, have an impact and implications here. And Chris, I remember when we were prepping for this, we talked about kind of this analogy of like self-driving cars where, if you've been driving for any number of years, you've seen this evolution of technology. And I lease cars, so every 3 years I get a new one to see what the technology's like. And it's getting better, but I still don't trust it. So I think we're a ways away. MJ, what do you think about this, where the industry's heading?
Yeah, I mean, I think I'm on the same page as the rest. I'm a definite fan of human factor, right? Somebody needs to be observing the metrics at some level. At the scale of our platforms, the benefit that we use it for now is really for anomaly detection, kind of what Nathan was mentioning there. And we have very fixed use cases where we might, let it take action from something, whether it be taking a physical server out of rotation or, something like that, disabling a user account, very basic stuff that's, pretty rudimentary. I'd like us to get more sophisticated with it, but again, it's only going to be as well as we can define those use cases, and systems are going to break in ways that you never planned for them to break. So it's going to be hard to really, figure what those are out.
Yeah, it's interesting you mentioned that. Like things do break in weird and fun ways, and I'm seeing this shift in the industry. They, a lot of people call it shifting left, right? Just basically getting closer and closer to the moment code is written versus building it and then deploying it and then observing it. I'm curious to get your perspectives on how that is actually happening within your organizations, if at all. Like, do you see more and more developers adopting more and more of the monitoring stacks earlier in their life cycle than they used to? Like, I'll give you an example. When I was a developer, my go-to tool after the console, just looking at the logs, was like the old rudimentary APM tools. They were very intrusive, but they gave me a lot of really valuable insights when the code was running. And so I started, making asks for budget to buy these tools. And that was a long time ago. How do you see that working now with observability and Kubernetes and all these distributed things? And, is that still happening? Is it fully happened? Where do you think we are on that?
Silence.
I'll go first.
We're all thinking.
It's still out there, right? At the end of the day, as we're building these platforms, we're finding more and more tools I think we need, or at least the development team thinks they need. What I tend to see is issues happen in production. The production support team, as a matter of survival, figures out what those tools are, and then those conversations tend to spark with development. And a lot of our new emerging platforms, a lot of folks that have that experience are bringing those tools with them that they learned from before, and teaching some of the, legacy platforms, what's out there and available. But I do see the culture shifting left as quickly as I'd like it. No.
Yeah, we've had kind of a piecewise like approach to this, or not approach is the wrong word, but like it's been very different team to team. So like we've had some teams that take on a bunch of operational responsibility above and beyond what most other teams are taking. And those teams tend to suddenly start asking for observability products. Tracing was first introduced into our ecosystem a few years ago when some of the people doing ops for the hotels stack decided they wanted tracing. And we're like, yeah, we're more than happy to help you build that. Let's work together and get a tracing thing out here. On the other hand, you have other teams at the company that basically don't know how any of the monitoring tools work. And it just varies depending on what they're being asked to do, what they're being held responsible for. It's nice when developers take an incentive here,
Yeah.
but it also tends to be the thing that spawns any systems that then get poorly maintained. It's the source of a lot of the fragmentation in our monitoring stack, but it's also the source of most of the new stuff. So
Okay.
I'm happy for it to be there.
Yeah, it's that thing we were talking about earlier, is like control versus innovation and things like that.
I think also it depends on the makeup of the teams. I think maybe Nathan, you have a similar thing, but we have distributed infra SRE type people at Sneak. They're not all located in my area, which I think I am strongly encouraging, actually, because it's not a bad thing. I want a community of practice. I don't want everything centralized, because then you have a different problem. And some of those teams that have the more infra-y type background people will take on a lot more. They're a lot more comfortable with doing things like that. That's how we actually started using things like Tempo. It's because we have some really strong kind of like Kubernetes observability engineers that sit in different places. And those were the teams that adopted it and ran a trial on it. And you know that we see this around the company. It's always the same set of teams, it seems like. The thing that I would say that I want to encourage it, but one thing that we're kind of fighting the tide of now at Sneak, and maybe MJ and Nathan, you see the same thing happening, is like, while that is a good thing and you kind of want to let that grow organically, is sometimes that introduces really bad patterns. Like we have some really bad patterns, particularly right now we're fighting a really big problem around high cardinality of our metrics. And despite my team having spent weeks trying to tidy some of this up, it still bites us fairly regularly. And it's a really difficult thing because you kind of like, you're trying to delicately balance the feedback and relationships with team. And you almost want to say, but it's not us, it's you. but you can't be like that, because the whole point that we're here is to like level up the practice and teach people the better way, you know, without it sound patronizing, but you know, that there is a better way, and that, you know, the reason why we run into these problems is because we've introduced too much organic kind of bad practice. So.
Yeah, we've fought a lot with that over the years, and we've actually managed to make significant improvements on how we deal with that, I think, in the last 2 years or so, which has basically just come from having better alignment of where the pain falls when these things go wrong, and then making sure that we're there to be the consultants that help them fix it. Not from the context of our system is down, it broke. It's, hey, your observability is degraded, let us help you, which helps make those conversations go a lot more easily. And we've gotten most of that just from like making sure that the failure domains, when you knock over a Prometheus instance, for instance, are a team. They're, hey, the Prometheus instance monitoring this service fell over because this service rolled out a super high cardinality metric and it's out of resources. Yeah. Let us help you adjust that resource budget and understand how much that's going to cost, or like change what you're recording so that it has a lower cardinality, maybe split that up over 2 metrics instead of taking their cross product, that type. Like being there as a team to help them is super important, but the pain doesn't have to fall on us if we manage the failure domains right.
Yeah.
And that's been hard to get right, but when in the few places that we've managed to, I think, get it really right, it's done a lot to help.
Yeah. We see that too. Like, I think OpenTelemetry will help here for sure, but you know, we're getting better at recommending best practices around cardinality, and we're thinking about it a lot internally because, you know, microservice architecture isn't going anywhere, Kubernetes isn't going anywhere, this problem's only going to get worse and harder. So we need to have a lot more best practices out in the industry that we share.
The microservice architecture and the general move away from monolithic services actually made this a lot easier to handle because of the failure domain isolation, right? If you have three things, then if the thing monitoring one of those three things goes down, that's a third of your things.
That's right.
Versus if you have 500 services and the thing monitoring one of those goes down, you need to fix it, but you're probably fine. It's a much lower urgency problem.
Yeah. I think Monty Python said it best. It's merely a flesh wound, right?
Yeah, but like in all seriousness, like it probably has neighbors in the graph that will notice the problem too if there is a problem while your monitoring is broken, and so it's less urgent.
I think there's just a lot of concepts to like understand as well. I think we take for granted the learning curve that we've all been on. Like even explaining to engineers that maybe have not set in the kind of areas that we've worked in, like how time series data works.
Yeah.
That can take a little while to get your head around, but then there's all these like different like queries and filters and concepts, and it's kind of becomes a little bit like sometimes a bit data sciencey as well.
That's a really good point, Crystal.
Yeah, and I think that's something that just takes time to learn. And again, this is like where I feel like we could reduce the barrier as well and try and upskill people a bit faster. Like one thing we did was we got Grafana, you all, to come in and provide training to us. Well, to the wider R&D org, because I felt that it was important to try and at least, lay some foundations around these concepts, because to a lot of engineers, they don't know what they are. They're maybe a little bit scary, or this is how we get the misuse, is because they think they've got a handle on it.
Yep.
And perhaps they don't. So
yeah, that's a huge challenge with us, is thinking that they know it, and unfortunately, a lot of our folks don't have time or the luxury of time, with their day jobs and their current business tasks to, invest in some of that. So, Steve, I think we need a master class here for, kind of the foundations.
Yeah, well, it's funny you say that, because, we're investing in our own education organization right now, and we definitely want to have a lot more of that going into next year, because I think it's important for companies like us to have opinions on this stuff, right? Like, we develop this software, we talk to many, many more customers than you all get the pleasure to do, because you have your day jobs. Or my day job is to talk to customers, and so is my team's. And so we're learning a lot as we do that. And I think, part of the way I see us passing this wisdom down to generation is through these standards, right? Like, look, we've learned a lot about telemetry. Let's make a standard that basically is a way to teach the next generation. Here's all the lessons learned encoded in this standard. I don't think anyone would really object with that, but it is this tricky thing where I know for sure when I was coming up as a developer, I thought I knew it all. My daughter would still say I do, but you have to learn these things. And if you make it easy by adopting a standard and you embed it in the tools and you just make it the default, we all know the power of defaults, right? Like, if we can make it the default, the good behavior goes up accordingly. So why don't we end on this topic of SLIs and SLOs? So MJ, I'd be curious to hear from your perspective how that's been evolving in your organization, and then we'll go around the horn and then we'll bring it to a close.
Yeah, I mean, we're kind of on the start of our journey for that. We're actually bringing in some consultancy to help us out, because one of the challenges we're having is actually what metrics to start with. And we're including the business in those conversations, right? So that it's not just technology that we're looking at, it's also what they're interested in too. So, we're just kind of in the first couple steps of that journey, and I hope the next time we meet, I have more details.
Right on. I love that you brought in outside help. That is mature, right? Like, hey, we can't figure this out on ourselves. Like, let's go get some best practice help. Nathan, Crystal, anything to add to what MJ said?
Yeah, I mean, we're also still in this like early stages for this, where we've got, I think, fairly robust checks across, or robust is the wrong word. We have broad checks that catch the really bad cases across most of the stack, and in that sense, we have a fairly mature system, but those are typically not adequate for a couple of reasons. One, if you have a system that can fail in a different way than just like, hey, it returned to 500, you have to specifically catch those for that service. And so the general purpose stuff doesn't work, and we don't have infrastructure to encourage people to produce those for their services yet, and that's one of the things we know we need. And the other is a consequence, I don't know if it's a good or a bad thing, of the aversion to hard failure, because you want your site to degrade gracefully, right? So you return a success code with worse results when something goes wrong. And so now your thing that's monitoring for errors doesn't see an error.
Yeah.
And figuring out how to have a system to track SLOs that correctly accounts for that stuff across many different ways of approaching that problem of producing a soft failure has proven time consuming. We're better than we used to be, but we've been working on this for a couple of years.
Yeah.
And we have a ways to go.
Yep. Crystal, why don't you bring us home with your thoughts on this, and then we'll wrap it up.
Sure. So at Sneak, I guess I'll just reiterate, my teams are fairly new. My SRE team is my newest team, having only been established about 6 weeks ago.
Oh, okay.
So yeah, it's a very new team for us, having started with our cloud platforms team and then having an SRE team now. So, but I have seen what good can look like at my last company. We got fairly far with this. And one of the early things that we've done is actually we spoke to the VP of product, which I thought was very important, yesterday, day before, and kind of spoke to them. They're kind of an advocate in this space anyway, which helps. But I think like it has to start with product and engineering working together to define the metrics, the KPIs. It has to tie to business goals in some way as well. But ultimately looking at things like user journeys.
Yep.
What are the user journeys? Because ultimately the whole point around SLOs is that we measure customer impact, customer happiness through these things. So we're trying to define like a top level set of metrics, which is no more than 4 or 5 across all of our products, and then have like a hierarchy that sits underneath that. I don't know. I've kind of mapped out, I think it's going to be 3 or 4 layers deep of kind of SLOs, SLIs. But that's where we are now. Like we haven't got very far, but I think we're at least putting together a strategy for how we want to do this. And some of our teams have been doing this already, which helps.
Yeah.
So it's not like we're starting from zero. We can actually use those teams as pilot teams, but also, advocate for it and get other teams inspired to do it as well.
Yeah.
But yes, I hope like also that, next time we talk, that I'll be able to say, yes, we've moved this forward very significantly.
Good.
I'm
really excited about that.
Sorry,
go ahead, Nathan. Sorry.
So when you say like 4 or 5 metrics, are you trying to build a like broad solution that catches like this is what we want our SLO to be for services in general? Or are you talking about having each individual service team pick 4 or 5 metrics from their service
would roll up? There's like an aggregate structure, I think, because I think ultimately you have to think about the audience. Like teams need to know how their services are performing in different ways. But my boss, the SVP of engineering, needs to be able to report back to his boss, the CEO, about how are we doing. And right now our metric is uptime, which is kind of a rubbish metric to use. So like there has to be some bubble up aggregation at the top level, and that's what we're trying to define right now. I think if we can get that right, the rest becomes a little bit easier.
Yeah, that's what we've been struggling with too. So I look forward to hearing what
we can compare
land on.
Yeah, me too, because that's what we're striving for, right? Especially in the payments ecosystem, right? Our clients are wondering how we're doing, so we'd like to be able to expose that to them at some level that, hey, we're having an issue, or no, we're not. Yeah. Definitely want to hear you back.
Yeah, I'm seeing this trend everywhere, like in the gaming industry, everything. And I think that's one of Grafana's superpowers is it gives you the ability to aggregate all this up and make that cycle of like collecting and reporting on SLI, SLO, SLA stuff is much easier when you have this kind of big tent looking at all of your different systems. I've seen that at a lot of different customers since I joined Grafana, and it's really encouraging. So again, thanks everybody for joining. I did the math. We have over 75 years of experience on this panel, so that's amazing. Lots to learn from, still lots of learning to do. But thank you for joining, and everyone that attended, have a great rest of the conference. We appreciate your time and listening, and hopefully this was really helpful. So MJ, Nathan, Crystal, thanks.
Thank you very much.
All right, everybody, have a good rest of the conference.
Hi everyone, my name is Richard Lamb and I'm the Senior Product Manager for Grafana Cloud. For this session, I'll be giving you a look into all the ways we've been improving the Grafana experience over the past year to make it easier to get started with your observability journey. We've developed a ton of bundled integrations that come with live dashboards, pre-configured alerts, and ready-to-go configurations that make it simple to harness the power of your metrics. First, I'll give you a brief overview of how we're building these bundled integrations in Grafana Cloud. Then you'll get to meet some of our engineers and designers who will do a deeper dive around Kubernetes, CloudWatch, and Datadog. So let's get started. At Grafana Labs, our DNA is rooted in the open source community. We build, maintain, and support the leading open source observability projects out there. And as is our namesake, we're primarily known for Grafana, that beautiful dashboarding and visualization tool that everyone, including you, I'm sure, know and love. Our mission at Grafana Labs has long been to let users democratize their data, to enable everyone to unlock the power of their data, regardless of where it lives, and to be able to unify it into one single place, to produce a single pane of glass, as we like to say. But we have to build and operate a lot more beyond Grafana too. Projects like Cortex, Loki, and Tempo allow us to offer an open source and complete open source observability ecosystem to the community. And with recent acquisitions like K6 and open source load testing tool, we're also expanding our expertise beyond just core databases. And it's the popularity and community support of our open source projects, which really allow us to package these individual things into something a bit more tight-knit, into a cohesive service. This is the basis for our Grafana Cloud product. With Grafana Cloud, we're able to back the beauty of Grafana, our bread and butter, with powerful backend databases for a total observability system that's compatible with metrics, logs, traces, and so much more on top of it. A little history first. We originally created Grafana Cloud as a way to just run a hosted Grafana instance. Lots of instances for lots of users. It was very simple. Then we added support to help our most advanced users of Prometheus run their largest and most complex metric systems. And over time, this expanded to our other open source projects, Grafana Loki and Grafana Tempo. This brought logs and traces to our Grafana Cloud product. Now we have an entire Grafana stack for our Grafana Cloud users. This was a natural evolution for us. And as Grafana Cloud became more mature, we realized that there's an even larger opportunity out there to help an even broader audience, beyond just our expert users. How do we help just anyone who's interested in observability by leveraging our open source projects? So we expanded Grafana Cloud to an even bigger audience back in January of this year with an all-new free plan that's seriously useful. It comes with 10,000 active series, 50 gigabytes of logs, and 50 gigabytes of traces. With so much in-house experience in building and dogfooding our own tools, we're the perfect system operators for a service like Grafana Cloud, where we manage, scale, and operate all of this on behalf of our users, whether it's a small team or a large enterprise with hundreds of millions of active series. So in addition to stitching together separate pieces into something that's fully connected and seamlessly ready out of the box for you, we're also making it super trivial to stamp entire Grafana monitoring stacks that are ready within just a few clicks and seconds. But we don't stop there. Not only do we want running a whole monitoring stack to be simple for y'all, but we also want the experience of using a monitoring stack to be simple. So with Grafana Cloud, you're not just using a service with experts as your system operators, but we're also building out a ton of net new capabilities on top of this. For instance, over the past year, we fully migrated WorldPings, the new Grafana Cloud synthetic monitoring service. We've also released close to 40 integrations. These are our bundled dashboards, alerts, and configs on top of the Grafana agent, which make monitoring an out-of-the-box breeze. So today you'll hear more about 3 of our Grafana Cloud integrations and solutions, which cover some of the most popular services out there: Kubernetes, CloudWatch, and Datadog. So I'll hand it off to Teddy to kick things off and talk about Kubernetes.
Thanks, Richard. Hi, my name is Teddy, and I'm a user experience designer here at Grafana Labs, and I'm supporting the Grafana Cloud team. Richard mentioned the solutions that we're building as a part of Grafana Cloud that stitch together open source technologies and make them easier for you to use out of the box. I'm here to talk about one such solution that I've been involved with, and that's the Kubernetes integration for Grafana Cloud. I'd like to begin by acknowledging the open source tooling that this solution is built on top of, the first of which is obviously Kubernetes, which you've probably heard of. It's an open source container orchestration system that automates a lot of the previously tedious and manual tasks associated with deploying, scaling, and managing your infrastructure. It's changed the lives of many SREs and app developers, or at least the ones that I've talked to in some interviews, and opens up their time to focus on more important things, like building and shipping cool software, and less time worrying about more tedious management tasks of infrastructure. Monitoring Kubernetes has become synonymous with Prometheus, and there are a few reasons why Prometheus is a really great tool, really good fit for containerized environments like Kubernetes. The first reason is that the Prometheus model is built on key value pairs, which is very similar to how Kubernetes organizes their infrastructure metadata using labels. This allows the time series data to be very flexible and accurate, and in turn, that makes Kubernetes metrics very queryable. Hint, hint, you could use a tool like Grafana Cloud to query it. There are a number of data sources that monitor different aspects of your containers and your workloads in Kubernetes. One of the data sources is kubestate metrics, which exposes Kubernetes internal data, such as replicas, pods, and deployments. Kubestate metrics actually natively uses Prometheus metrics format. The last reason that Prometheus is a great fit for Kubernetes, a perfect match, if you will, is that Prometheus servers auto-discover scrape targets and can also be configured to filter and match container metadata, making an excellent fit for ephemeral Kubernetes workloads and makes them very monitorable so you can dig down deep into your infrastructure. Finally, Prometheus is the tool that powers Grafana Cloud, so it makes Grafana Cloud a very awesome fit into this trio as well. So what does the Grafana Cloud solution look like? We released the first version of our Kubernetes integration earlier this year, and we've made a ton of improvements on the way, and we have a really busy roadmap going forward. It's all built on top of our open source Grafana agent and the Kubernetes mixin. I'm going to speak about a few of the pieces that we've built, including UI and some configuration steps that make it really easy for you to get this running up and running out of the box with little hassle, and also make monitoring a lot easier for you. So first, beginning with the agent is a lightweight observability data collector that's optimized for sending metric, log, and trace data to Grafana Cloud. So we configure the agent to periodically scrape targets from your Kubernetes clusters with just a few steps on your end. And right now we have it configured to scrape endpoints like Kubelet and cAdvisor. It's done in one quick click from you. We've built a UI called the integrations walkthrough, which allows you to really easily get up and running with many integrations. We provide a list of instructions for you, and we provide the code snippets that you need to configure the agent to scrape your Kubernetes clusters. In the future, in the near future, we are introducing Helm charts into the instructions to make the config even easier. And we have a number of additional configuration options that we walk you through in our documentation, including collecting or configuring node exporters and collecting container logs. And we hope to provide those instructions here in the integrations walkthrough in the future, as well as making it easier for you to do a allow list for metrics. So you can pick and choose which metrics you want the agent to scrape. I mentioned the agent is currently collecting Kubelet and cAdvisor metrics. We hope to have it configure it to collect container logs and node exporters as well. And on our roadmap, we have kubestate metrics and Kubernetes coming to the agent as well. So these are all metrics that we hope will make it easier for you to get your data into Grafana Cloud so you can query, alert, and visualize on it. Finally, we provide out-of-the-box dashboards as a part of the integration so that it's really easy for you to get up and running and monitoring your Kubernetes workloads really quickly. Today, we provide just 6 dashboards. They were a part of the original Kubernetes mixin. We're hoping to expand this list based on new data sources that we're incorporating as a part of the agent, as well building out new dashboards and views based on the research that we've been doing to understand what Kubernetes users' needs are. I've been involved with this research and have been collaborating with some self-serve team members and a couple of the engineers on our team to talk to Kubernetes users, understand what metrics are most important to them, what views are going to be most helpful to, say, get your workload sized correctly, or troubleshoot some problems of overconsumption or something like that, and design views based around those needs. So we're hoping to provide a lot more out-of-the-box views in the future. I'm going to give a quick demo just to show you how easy it is to configure the agent to scrape metrics from Kubernetes. We're here in Grafana Cloud, and if you go to the integrations walkthrough and search for Kubernetes, we provide instructions here And we provide all the code snippets that you need so that you can do the work on your end. So there are a couple of steps that I'm not showing here on your end, but we provide step-by-step instructions here. And then once you finish that, you can click Finish Installation. And we give you a link to all of the dashboards that we provide as a part of the integration. So these are the ones available today. Like I said, this list is going to grow. We hope to also introduce some guided navigation so that it's easier for you to get to the dashboards that are most relevant to you based on your interests. And you don't have to page through dozens of dashboards looking for what you need. I'm going to quickly walk you through what's on our roadmap. So I spoke a little bit about the data sources that we're going to be building into the agent, so I won't go over that again. But in addition to that, we're hoping to beef up our out-of-the-box monitoring by providing more and better dashboards. We hope to also include some default alerts in the integration, and we'll potentially be including some new views to better help manage your infrastructure and drill down from your app services to pods and be able to troubleshoot those. In addition to that, we're making configuration easier. We're making it more packaged and providing instructions all in one place. Also coming very soon is the introduction of Helm charts. Finally, we're providing support for Kubernetes as a platform. So say if you want to install and integrate the Nginx integration and monitor your Nginx app running on your Kubernetes cluster, we are providing support so that you can click Kubernetes as the platform by which you install that integration. I'm going to throw in a quick shameless plug here. I mentioned that I've been doing some research to understand the needs of users, app developers and SREs monitoring their Kubernetes workloads and clusters. If you'd like to talk to me, you can reach out to me via email or the Grafana community Slack. I'd be more than happy to nerd out with you about Kubernetes. I've learned a lot about it over the last few months, not having ever been an SRE, and I'd love to chat with you about it. So feel free to reach out at any time. Kubernetes is just one cloud solution, and Christian is going to talk about another cloud solution, which is AWS CloudWatch. Thanks.
Hi, everyone. I'm Christian. I'm a software engineer at Grafana Labs. I'm excited to talk about our new solution for CloudWatch metrics. This new integration is available today to all Grafana Cloud customers. The CloudWatch integration is a managed solution that allows you to quickly connect to your AWS account, import your metrics into Grafana Cloud, and start using some pre-built dashboards to monitor your AWS cloud infrastructure. The CloudWatch metrics integration is a managed service that allows you to automatically pull metrics from AWS CloudWatch into Grafana Cloud. Compared to other solutions, you don't need to install any additional components with this integration. We manage all the infrastructure needed to connect to the CloudWatch API, fetch metrics data, and store them into Grafana Cloud. Our systems will request metric data from the CloudWatch API every few minutes and convert them into Prometheus metrics. These metrics are then stored into our Prometheus-compatible backend alongside all other Grafana Cloud metrics, all in one place. This means that once the metrics are stored, they can be queried at no extra charge using the PromQL language, and you can benefit from the long-term retention, reliability, and performance of our managed Prometheus backends. CloudWatch is such an important monitoring and observability service in AWS. In fact, one of the most popular Grafana plugins is the CloudWatch data source. Let me explain the difference between the CloudWatch data source and the new CloudWatch metrics integration. With the data source, you can query metrics and logs straight from the CloudWatch API. For example, you can select an AWS namespace and search for all available metrics. And then you can apply statistic functions and filter by dimensions. This way, you can quickly explore and graph CloudWatch data points in Grafana. However, this can be quite expensive. Each time you pick a metric or dimension, and each time you execute a query, the data source will make a request to the CloudWatch API. And each new request counts towards the CloudWatch API free tier limit. Now, imagine you could have all your CloudWatch data stored into Grafana Cloud as Prometheus metrics and run unlimited queries leveraging the performance of our Prometheus backend. With the new CloudWatch metrics integration, we fetch data points from the CloudWatch API every few minutes, translate them into Prometheus format using an open source Prometheus exporter, and store them for long-term retention. So you can access and visualize your data by querying the managed Prometheus instances in Grafana Cloud, and you don't need to query CloudWatch anymore. Using PromQL, the popular Prometheus query language, you can access your CloudWatch data as regular Prometheus metrics. Say, for example, the 98th percentile duration of Lambda functions becomes a Prometheus matrix that you can query using the function name as a label. Also, to get you up and running very quickly, we have included some pre-built dashboards that are installed into your Grafana instance when you set up the CloudWatch metrics integration. So you can see how this managed solution can potentially save on CloudWatch API costs. Grafana Cloud collects metrics data points only once, but then we store them into our Prometheus backend that you can query again and again without additional costs. The setup process for the CloudWatch integration is also very simple and secure, and I want to show you how it works. First of all, you don't need to generate any access key and don't need to share any secret with us. In fact, Grafana Cloud uses role delegation to securely access your AWS account. And with CloudFormation or Terraform, you don't need to manually set up any resource. So creating the access policy and role only takes a couple of minutes. Your next step is to create a scrape job. Choose the AWS availability regions where your services run, and Grafana Cloud will connect to the regional CloudWatch endpoints and automatically discover your resources using tags. You can also limit access to only the AWS resources of your interest. Select which services you have configured in your account and regions, and then the CloudWatch integration will start pulling data in the background. At the moment, we support some of the most popular AWS services, such as EC2 and Lambda, but more will be added soon. And finally, you can organize and manage scrape jobs based on your needs. For example, if you have multiple AWS accounts, you can configure a different job for each one of them. And after the initial setup, you can always edit a scrape job to add more services or regions. As I mentioned before, the CloudWatch integration comes with some pre-built dashboards, as you can see here, so that you can immediately get started with AWS monitoring and observability. And of course, you can always access and explore raw Prometheus metrics from Grafana and use them to build your own custom dashboards. And now, time for a quick demo. I'm going to use my personal Grafana instance, and you can see here the list of available integrations. I'm going to choose the CloudWatch metrics integration and use this panel to set up a new scrape job. So I'm going to add a scrape job. And following the instructions, the first thing to do is to create a new AWS role, which I can do automatically using CloudFormation, for example. This is a step I've already taken before. So the next thing to do for me would be to connect Grafana Cloud to the AWS account. And I need to paste here the ARN for the role that I just created. And then I'll select the regions where my services run, for example, Europe North one, and then test the connection between Grafana Cloud and AWS. Finally, I'll create the scrape job using this name, prod account ObsCON, and selecting the list of services that I want to use, such as EC2 and Lambda. I create this scrape job. And now Grafana Cloud will start pulling metrics in the background for me. And I can also find a new set of dashboards installed into my Grafana instance. This will take a few minutes, of course, to start pulling data, but I can show you the data I collected just the other day from my EC2 instances. For example, in this dashboard that is automatically installed after the scrape job setup, you can see CPU utilization, network traffic, and a lot of other metrics for my EC2 instances. All right. So time to wrap up. The CloudWatch metrics integration is available today at no additional cost to your standard Grafana Cloud plan. Billing and usage for the CloudWatch data imported into Grafana Cloud is just like any other active series for metrics. And again, this is a managed service, which means you don't need to install and manage any new infrastructure. If you are an AWS customer, go connect Grafana Cloud to your AWS account, and metrics data will be pulled automatically into your Grafana instance. We just launched the CloudWatch integration, and we are working to continue extending access to the most popular AWS services. Next to CloudWatch metrics, in the future, we will also be adding support for CloudWatch logs. So not just metrics, but even application logs will be automatically ingested into Grafana Cloud and stored into our managed low-key backends. As you can imagine, we're also planning to extend the list of managed integrations to other cloud providers and cloud services. If you have any particular request, please get in touch. And now my colleague Jesus will talk about another cool feature of Grafana Cloud, the Datadog translator.
Thank you, Christian, and hello, everyone. My name is Jesus Vázquez, and I'm a software engineer at Grafana Labs. Today, I'm going to talk about Grafana Labs Datadog Translator. But first, let me give you a very quick introduction to our Datadog Enterprise plugin. As you may already know, Grafana has this Big Tent philosophy where we see Grafana as the tool you can use to visualize metrics coming from any existing technology. A very powerful tool in this ecosystem is Datadog. And in fact, our customers asked us in the past to provide an integration they could use to see their Datadog metrics in Grafana. This is how the Datadog Data Source plugin was created a few years ago. Fast forward to today, we are happy to announce a deeper Datadog interoperability that includes an experience that is not limited by Datadog API rate limits, the ability to host your Datadog metrics directly in Grafana Cloud, and the ability to import Datadog dashboards into Grafana Cloud. All right, let's give you a more closer look. Our service offering is a fully compliant Datadog API for both reading and writing metrics. What does this mean? Well, since it's a compatible API, your engineering team will not need to rewrite any sort of instrumentation code. Instead, the Datadog agents that are running on your infrastructure will require a very small change composing a single line of code that I will show you on the next slide. Under the hood, the metrics that you'll be sending to us will be stored as Prometheus metrics on our backend. That being said, though, your engineers will be able to continue querying the data using the Datadog query format, thanks to our query translation layer. Regarding the feature parity with Datadog, we are proud to say that all metric types apart from distributions, as well as the most commonly used Datadog functions, are supported. Now, here is the single line of code that will be required on the agents to start using our service effectively. This change will stop your agents from sending metrics to Datadog. And we understand that during the transition or evaluation period, you may want to keep both monitoring solutions, at least to evaluate if we can handle the load and the use cases that you have. For that scenario, we have this alternative configuration where the agent keeps forwarding metrics to the Datadog endpoint as well as to our cloud. Last but not least, we have the Datadog Dashboard Translator tool that can help migrate dashboards over to Grafana UI. It is a very simple CLI tool that I will demo in a second. But first, let's take a look at this Datadog dashboard on the left. And this is how it would look like in Grafana once it's translated. Pretty similar, if you ask me. Now let's begin with the demo. We have 3 points in the agenda. First, we're going to set up a Datadog data source in Grafana UI. Then we're going to show you how to query the Datadog data source using Grafana. And finally, we are going to translate a Datadog dashboard in live. So let's get on with it. We want to go to our Grafana UI And in here, we want to select the wheel and settings wheel, and then click on data sources. Hit on the bottom, add a data source. And in the search box, we want to filter by the name of Datadog. Now, this item will only appear to you if you're an advanced user or a pro user with enterprise plugin license. Now we want to click on select, and it will prompt us with this formulary. The URL endpoint will be by default pointing to Datadog, and you can leave it as it is if you want to use Datadog's official API. Then you would have to set up the API key and the application key. Now, in the case that you wanted to use Grafana Cloud as this storage backend for your metrics, you would have to replace this with a valid Grafana Cloud URL that we will provide to you, as well as enable the basic authentication. In here, you will have to enter your organization ID and your JSON Web Token password, as well provided in the organizational settings. Now, I can delete this one and show you two that are actually properly configured and working. We have the first one, which is pointing to Datadog official endpoint. As I said, configured with the API and the application key only. And then we have the second one, which is pointing to Grafana Cloud. And this one is pointing to our development instance and has basic authentication enabled, again, with the organization ID and the JSON Web Token password that I mentioned before. Now we want to test these two data sources, so we can jump to the Explore UI in here. So we want to go to the left menu, hit on the Explore icon, and then at the top of the UI, we want to select the Datadog official data source first, because we want to actually check the metrics that are available on Datadog. And there is this particular metric that all agents are reporting, which is whether or not the agents, the Datadog agents that are reporting metrics are actually running or not in the infrastructure. So we can click on the metric dropdown, click on Datadog agent running, and this will retrieve data in a couple of seconds. And we see that the agents are running. In this case, one means that it's online, and we have the data points down below. Now, if we swap the data source and we select the Grafana Cloud one, we will then retrieve data from Grafana Cloud instead of Datadog, and we should see the same information. And the same information is retrieved, the agents are up. Now, of course, this use case is perhaps a tad too simple. So we have prepared a more complex and real scenario. We have prepared this Datadog dashboard that has a list of system metrics panels. They are showing CPU usage, memory usage, disk utilization. So we want to go to the upper right wheel, and in there we want to select Export Dashboard JSON. Now this will create a JSON file with all the panels information that you're seeing, and you will be able to download it to your computer. We have already performed this step and have prepared this terminal where the JSON has been downloaded. Now, if we enter the name of the Datadog Dash Translator tool and we hit enter, we will get a help message where we see that it is offering the translate command. So we want to say Datadog Dash Translator translate, and we can also consult the help message for this command. And in here we can find the flags that we need to use to translate our dashboard. So we want to say Datadog Dash Translator translate minus input, the system's metric combined JSON that we downloaded, minus output translated JSON. We hit enter, and in a couple of seconds we get our Grafana dashboard written to disk. So the Datadog dashboard has been successfully translated. So we can now jump back into the Grafana UI, and in here on the left side menu, we can click on the plus icon, and then on import, then upload a JSON file. We want to select the translated JSON, which is our Grafana translated dashboard, and then we want to click on import again. And all panels have been successfully translated. I'm going to switch back and forth between the tabs so that you see that they are looking pretty similar. the same information is being retrieved. Now, you should notice that the data source that we are using is Datadog, but all the data is also being forwarded to Grafana Cloud. So if we swap the data source with our Grafana Cloud instance, so they should be retrieving data from our backend, we should be able to see the same information as well. We give it a couple of seconds, all panels have reloaded, and the same data is being shown. So that's validating that the technology is working as expected. Let's continue with the presentation. Now, that will conclude the demo and hopefully clarify the improvements that were made to the Datadog integration in Grafana. Before I finish the presentation, I'd like to add some final notes. The Datadog translator tool that is already publicly available, but it will only be available to you if you're a pro user or advanced with an enterprise plugin license. The documentation clarifying all the steps that I've taken and how to set it up properly is already available on the link that's shown on this slide. But also, since clicking on slide links is complicated, you can search for the terms Datadog metrics Grafana Cloud, and you should be able to find it. Finally, if you aren't already using Grafana Cloud, sign up today for a forever free plan to try any of these integrations or any others in our catalog at no extra cost. That wraps up our session. Thank you all for listening, and a big thank you to Richard, Teddy, and Christian for putting this session together with me. We'll now have some time for a Q&A.
Hey everyone. Like Jesus said, we do have time for a few questions before we need to wrap up. The first one's for you, Teddy. Do you use Kubernetes or dog food in any way outside of the task of designing UX for it? If not, how do you keep yourself acquainted with Kubernetes?
Thanks, Richard. I'm going to answer that in two parts. So first, at the org level within Grafana Cloud and our team, we use Kubernetes extensively internally. Actually, all of our platform is orchestrated through it. And also, as with most services we deploy in Grafana Cloud, we plan to roll out the integration widely internally as well, working with our own engineers to kind of test it out and make it better. I would say then second part of this question, on a personal note, I didn't know anything about Kubernetes before starting to work on it. My first introduction was actually earlier this year. We hosted an internal hackathon that was really promoted by our SLT, which was awesome. And I worked with one of our engineers who used to be an SRE to build out a service catalog concept for Kubernetes. And I really dug into it there. I did a ton of interviews this year to learn about how we could make our integration better and do some personal learning for myself. And I think I did 10 interviews with members of our team who were past SREs or are SREs at Grafana Cloud and use the Kubernetes integration here. So I've done a lot of personal learning. I don't have any instances that I manage myself, but hoping to do that as I get deeper into the project.
Awesome. Thanks, Eddie. The second one's for you, Christian. What is the difference between using Grafana Cloud's CloudWatch integration versus just accessing the same data from AWS directly?
Thanks, Richard. So with the CloudWatch integration, basically you import CloudWatch metrics from the AWS API into Grafana Cloud, and these metrics are translated into Prometheus format, which means you can benefit from our hosted Prometheus backend with long-term retention and for high performance, and you can basically use PromQL to access your CloudWatch metrics, and you don't need to query them from the CloudWatch API anymore. So you will use Grafana as a single pane of glass, basically.
Thanks, Christian. Unfortunately, that's really all the time we have today for questions. Thank you again, everyone, for attending. If you do have further questions, we'll be in the Grafana community Slack, so ask us there. Enjoy the rest of ObservabilityCon. Thanks, everyone.
Hi, I'm Frank. I'm here to talk to you today about migrating from an in-house graphite solution to Grafana Cloud. And I'm going to talk about what Cambi is, who I am, why things were the way they were, how we try to improve it, what we found out by looking a little bit closer at what graphite is doing, how we could solve those things we found, and also ways to go into the future in a more reliable way, and a couple of takeaways. So a little bit about Cambi. Cambi is a sports betting technology provider that provides technology for regulated global betting and gaming industry. There are more than 850 employees in Malta, Australia, the Philippines, Romania, Sweden, the UK, and US. And it's a company that's passionate about the free open source software technologies as well. There are about 500 different microservices in production that are producing metrics to graphite at the moment. And this adds up to around 200,000 incoming metrics messages per second when you add the prod and test together. So a little bit about me. I'm a site reliability engineer at Cambi, located in Stockholm in Sweden. I'm pretty passionate about observability. I really like free open source software as well. I'm a bit of a heavy metal fan. And as you can see from the image there, I'm occasionally standing in front of lasers. So a little bit about what graphite used to be. And we used to have what I perceive to be a pretty normal setup for graphite. It's all based on Python. And you have around 500 of our services feeding into an HA proxy. And that divides the load between 6 instances of Carbon Relay. And the reasons why there are 6 instances is because they are not multi-threaded. So to get sort of CPU scalability, you have multiple instances. So the HA proxy will distribute the load between these one by one in a round-robin fashion. And then these Carbon Relay nodes forward the data to the Carbon Cache nodes that store the actual data as Whisper files. So there are problems with this, or problems became more evident after a while. We started dropping metrics, and disk space was running out. And what was most noticeable was CPU running out. I could basically not log on to the Carbon Cache node sometimes because they were just not responsive enough. RAM was running out as well a little bit. And this was sort of a side thing for many of us, but we ended up spending so much time just trying to keep this solution running. So we recognized that maybe the Python components were not as efficient as we had hoped. So we replaced Carbon Cache with GoCarbon, which does the same thing, but it does it, well, with code written in Go instead, which handles parallelism better and is a bit more speedy. And that fixed our CPU problem. But something else unexpected started happening. We were still dropping metrics, a little bit less, but we were still dropping metrics. Disk space was still running out, but most of all, our disk I/O was just not enough. We could not push data quickly enough to disks for the disk to keep up. So we were buffering a ton of stuff in memory, and eventually the services just got restarted. And this turned out to also be extremely intensive to maintain, almost like a half-time position, just keeping this up and running. So we tried the simple solution, but we realized that, okay, we need to figure out what's going on here. And the best way we could do that was basically use TCP dump the network traffic into really big text files and just use a bunch of Perl scripts to just get that data correlated and figure out generate some reports, which is Perl is great for generating reports. I wouldn't subject it to my colleagues though, normally. So what did we find after doing all this? Well, we found that many metrics were being sent at a more frequent interval than they were actually stored at. We were mostly storing metrics at a maximum 30-second precision, but many services were sending in data at every 1 second or even multiple times per second. And we also found that actually most of the values of the metrics were just zeros, always zeros, never anything else, or not a number even. So that's really something that we thought, this is weird and maybe this data is not useful. So what can we do about this? I mean, scaling out Graphite would be good, but we were running Graphite in an on-prem data center, and getting more resources there was difficult at the time. Also, expanding a classical Graphite cluster without having a long downtime, especially if your cluster is really overburdened, is hard. We could not figure out an easy way to do it without affecting our dev teams. I mean, we could go to our developers and say, well, maybe stop sending in metrics that are just not a number or zero all the time. But we have around 500 in-house services, and they're managed by over 50 dev teams. So we couldn't realistically go to all of these people and tell them to drop everything just to do this. And we couldn't give up either. I mean, the house was burning now. We needed to fix it. This affected how we could view our systems and how our environments were doing. So we found a software solution, Hadrianus. So the idea there was that we could replace the HA proxy, which was distributing the load between the carbon relays, with a little simple service written in Go that was aware of these graphite metrics. So if we as human beings could see that something was wrong with the metrics, well, we could just write code that implemented the same decision making and went, well, this metric has always been zero. It will clearly, obviously, only be zero. Let's not send that to the rest of the graphite cluster. So this new little application-aware firewall load balancer has some features. It's pretty fast. It's very small. It handles the load balancing round robin that we used HA proxy for. It also is capable at the moment to mirror traffic to multiple graphite clusters. And also, let's say that our logic for deciding if a metric is completely off the wall, and it's really important to have that metric, even if it violates our logic. There's also an allow list functionality that says, well, this, no matter what, this metric, pass it through. And then the most important functionality is dropping incoming metrics that don't conform to the Graphite line protocol. We have plenty of problems with that. Metrics that come in too fast for the Graphite endpoints to handle. If you have too much data coming into an old-fashioned Graphite cluster, it doesn't handle that well. And also the big point is if the metrics are judged to be stale or meaningless in some way. And stale here means that they only send in one value, like zero, ever. So that's the meaning of stale in that context. So we put this in place. And how did that go? Well, we received an 80% reduction in load. All of a sudden, disk I/O was still high, but it was able to push this to disk eventually. Memory utilization, I mean, still kind of high because of the disk I/O, but completely fine. Things didn't just randomly die because they ran out of memory, for instance. So why did we call it Hadrianus? Well, it's the name of a Roman emperor who built a wall across Britain around 122 AD to keep out the troublesome tribes to the north at the time. The logo is a bit special looking, and we kind of like it that way. I always sort of wanted to be in a black metal band, but I could never, learn to play the guitar or be able to carry off the haircut. So, yeah. So now we sort of got our metrics working, but it was just barely hanging on. And we continually grow as a company, and we get more and more metrics all the time. So we need to figure out a solution for that. Also, we want to start using Prometheus instead of Graphite because it has more popular support and works slightly better in Kubernetes. At the same time, we want our developers to not really experience any major outages or, feel that their user experience is negatively impacted. So we started to think, well, we can't scale Graphite. Maybe someone else can. So this is when we modified Hadrianus to also send the data in a mirror replica to somewhere else, a third-party provider, perhaps. So in this case, among other providers, we evaluated Grafana Cloud. And we were able to basically test out Grafana Cloud's metrics handling abilities by basically sending our whole production data load, the whole horrible amount of data, straight to Grafana Cloud to make sure that they could handle it. So Hadrianus it works great for us right now. We want to improve it as well. We want to make it slightly more reliable. It is very reliable at the moment, but there are some edge cases where it can be improved. And also in some of the blocking logic, it can result in a poor user experience sometime. And we have some really good ideas for improving that. And it's open source. It's on GitHub, on github.com/cambisports/Hadrianus. So please check it out if you're interested. Let us know if it works for us. Let us know if it doesn't work for you. What doesn't work for you. And if you want to contribute, yes, please. So what are a couple of takeaways from all of this? Well, Grafana Cloud was a pretty good fit for us. They support Graphite, which is what we've been using. They also have a good migration path to Prometheus, and we can do it gradually. And also, we already have Grafana in-house, and just putting it in the cloud would be almost an identical user experience for our dev teams. And we're also hoping that in our site reliability engineering team, we hope to replace our existing Elasticsearch solution in AWS with Grafana Labs Loki somewhere down the line. And another takeaway is, writing software to overcome your problems is fun. It gives you power over your situation. Oh yeah, and we're hiring. So check out cambi.com/careers if it's interesting. Thank you. Hi. So I'm actually a bit unsure which questions to start with. And well, I'll start from the bottom. So the developers, how did they feel about the introduction of Hadrianus? And I'll be perfectly honest, Hadrianus did and does to some degree involve throwing away some metrics. So that is part of the improvements we want to make, because, for instance, if an application is basically dead, most of the, well, not sending much change metric for a while, it will be muted for a while until it comes back, which leads to gaps in the data. We have an idea for getting around that, but yeah, right now that's how it can be. Yeah. Well, we haven't actually gone out and called them invaders or developers, invaders from the north to their faces. I think that might actually have led to a bit of a controversy. Yeah. And yeah, Elasticsearch with Loki. Well, we are also, just like we were managing Graphite on our own, we have been managing Elasticsearch. And we set it up in AWS in a scalable way ourselves. And we were not prepared for how much work that it would actually be. And we would be really happy to have someone manage that for us. And we didn't want to write much custom logic, and Loki seemed like a good fit. And also we can integrate our metrics with our logs in a single view, which is nice for us. Yeah. I think those are all of the questions I can see. Well, if that's it, then thank you.
Hello, everyone. I'm Vinod Ravi. I lead platform engineering teams within the consumer banking division of JP Morgan Chase. My talk today is about how we can apply the idea of incremental learning using observability-driven development. I'm going to highlight the benefits of shift-left resiliency practices, and by doing so, how can we enable our business to move rapidly? This talk has two parts. First part is mostly theory. I'll share my thoughts on how we can embrace complexity. The second part is putting the theory into practice. I'm going to attempt an end-to-end demo to showcase how developers can benefit from applying observability and resiliency practices to their workflows. So let me talk about a problem here. For those familiar with probability or queuing theory, which I assume will be most of the audience in this conference, here's a good example of linear thinking put into effect. The way the supply chain disruption problem is currently handled. The assumption was that by increasing the port operating hours, we can eliminate delays in shipping goods. But in reality, the plan didn't work out as expected due to external factors. This has unintended consequences as well, like increase in average wait times for ships to dock. Tiny changes like increasing a port's operating hours in the grand scheme of supply chain things can have compounding effects on the overall system behavior. This compounding effect can in turn lead to chaos. Conventional thinking is not suited to address problems that are nonlinear and dynamic in nature. Here, I'm going to introduce you to a sense-making framework. The sense-making framework that I'm talking about today here is called Kahneman. It was created by Dave Snowden. The goal of this framework is to help people figure out how best to approach their problems. This framework is not going to tell you how to solve your problems, but it'll tell you how to make sense of the problem. You can take any problem and slot it into one of these four domains. The problem that I mentioned on the previous slide, longer wait times to move shipping goods, should be considered as a complex problem. Problems that deal with unknown unknowns, for instance, fall in this complex domain. In order to deal with complex problems, we need to probe, sense, and respond. In this domain, you're constantly running experiments, gathering feedback from those experiments, and you observe the signals to decide if you like to further amplify or dampen the signals. At Chase, we deal with transactions unlike many other institutions in the world. We're constantly experimenting and solving problems by moving them between the complex and the complicated domains using modern agile ways of working. I can give an entire talk on this framework, but that's not what this talk is about. If any of you are interested to learn more about how I use Kahneman framework, please DM me. The approach to incremental learning, the approach that we've taken to incremental learning is we're starting to see more and more projects shift into a state of dynamic, into a state of organic growth. They continue to evolve based on user feedback and constant experimentation. In order to support this rapid experimentation, we're beginning to embrace new working methods and practices. But what we need to acknowledge is the fact that the mental models of the people who create apps and the people who maintain them are different. On the one end of the spectrum, we're designing the system to have a desired effect, write code, build, and deploy continuously. And on the other end, we interact with the same system to monitor and observe, to make code more reliable, and by adding more resilience. These are two separate cognitive loops. Using dashboards to capture and share context isn't going to help us find anything of relevance about the systems we're dealing with. Our systems today have so many moving parts and are constantly in flux. Modern workloads are by default are highly distributed in nature. What all of this means is data is coming to us at very high rates. More data also means less insights due to noise. Our approach to sense making is to apply learning incrementally and building knowledge over time. Learning can only happen by allowing people to have focused attention. Paying attention to the wrong things will hinder our ability to learn. In this model, we encourage and promote our teams to actively engage very early on in the design and development phases. As the code evolves, proactively load test your services using tools like K6. Introduce turbulent conditions in your system using chaos tools like Gremlin. Introduce other forms of testing like fuzz testing for black box solutions to expose flaws in the software by causing the systems to crash. All of these activities will create error feedback loops that will allow us to compare our predictions with reality and adjust our models of the real world. And in order to amplify or dampen the signals coming out of these feedback loops, we need good observability tooling. And for this to happen, we need to leverage open standards like OpenTelemetry, open source libraries such as SQL Commenter, open source tools like Loki, Prometheus, and Tempo. These are all great projects. And finally, we should have mechanisms in place to consolidate and generalize what we learn. Specs like open annotation and projects like Hypothesis provide a platform for teams to have meaningful conversations from which context can be derived. The model that I propose here is based on the research done by cognitive neuroscientist Stanislas Dehaene on learning. I recently read a book titled 18 Tiny Deaths by Steve Goldfarb. It's a book based on the works done by Frances Glessner Lee, who's widely regarded as the mother of modern forensics. I was really fascinated by how she used dioramas to recreate crime scenes in minute details to advance the study of death investigations. Here I'm going to use her teaching methods of observation to explain my approach to incremental learning. Switching terminals. What I have here is I've created a utility to help me narrate the story. So I'm going to go ahead and fire that off here. Go to the story. I've created a fictitious company called Climate. Here, the mission statement for Climate is to discourage people from eating meat and effectively reduce greenhouse gas emissions. It's a nonprofit. It's a small size company with 3 people product team. The names that you see here were generated, were fictitiously generated using a random name generator behind the name that's mentioned right here. Ani is the product owner. She believes that making mistakes is the best way to learn. We have Natasha, who's the creative, the developer. She thinks she is a software engineer. She believes she's a software engineer and not a programmer. To her, all code is technical debt. And Deepak he strongly dislikes big data. So let's go down a bit. What we're looking at here is the pitch. The team believes in the Basecamp's shape up model to ship software. So Ani is going to create a pitch. She's working on a new campaign with her team of climate sustainability experts and looking at the CDP data set. CDP stands for Carbon Disclosure Project. So what she's doing here is she's looking at a CDP data set and a solution that was submitted in a Kaggle competition. Abdul Wahab was the submitter. He describes the problem of food waste and overconsumption, and he also comes up with a set of KPIs. So Ani's interested in 2 of those KPIs. One is the meat per capita, and the other is the meat overconsumption. She's looking to create a dashboard to expose these metrics, and she wants to put all this together in a week. We're going to focus on just the API endpoints for the scope of this narrative. So let's dive right into the team interaction. So day 1, Ani wants Natasha to look at the Kaggle notebook. She's what she listed in the pitch. Natasha is already trying to get it working on local in a couple of hours. She then moves on to data wrangling. She wants to look at how can she translate the code used to analyze all of the data into more of a consumable API. So she spends the whole day doing that and comes up with a model where she's created 2 tables, 2 simple tables, cities and city responses. The city responses are aligned to the city questionnaires that the data set has. It's about 1.5 million rows approximately. And she has created a utility table that would connect those 2 and pull the population from the recent history. All 3 tables are related using the city account number, as you see here, and a /meet city endpoint has been created. And Natasha wants Ani to check it out. Ani goes and checks out the city endpoint. She's happy with what she sees. The response is for the endpoint is /city/Moscow, and she says the name of the city, the population 1.26 million, population year it was reported, 2019. So she wants to move forward. At the same time, Deepak joins in. Deepak wants Natasha to run this endpoint through Trials of Chaos. So Natasha thinks it's fun, so she's going to go play the game, Trials of Chaos. So let's switch to the Trials of Chaos. So what you see on the main screen here is are a few things. So Natasha logs in. she is going to see her endpoints in her and the associated application, or the app and the associated endpoints. City and cities, these are hard coded. We have not put an effort to make this more dynamic, but all of the data behind the test are dynamic. They're all real. We're not faking any of that stuff. What you see here is city. So Natasha picks on the city endpoint. She's going to start the experiment. As you notice here, she comes to the level select screen. The reason why it's in level 1 with no stars is because she hasn't put this endpoint to test. So she's going to go run this endpoint. Okay, the experiment's initialized. We edited a bit of it. It takes about a minute to initialize the experiment. We're actually in the run page now. So what you're seeing here is a service map, a simple service map. In this case, a front-end API and a back-end. For the scope of this demo, like I said, we're only interested in the endpoints that Natasha is working on between API and the database. Right now, the test is being executed against the /cities endpoint. At the bottom left, you have the different stages. The stages are metadata coming out of K6. The spec has the duration and the active views. Like, it's pretty self-explanatory here. And on the graph here, we have a couple of interesting data points. I'm going to go through the yellow lines first. The yellow line has the active views, which is a point in time here. As you see, this should align with what you see in the stages here. And then the blue data point, the blue line plot corresponds to the P95 response time. So when I highlight one of these data points, you're going to see the response time for the P95 being listed up top. So as I hover over each of these points, you're going to see that. And to the top left, you're going to see the max duration and the total request. So as I hover over this, one interesting thing is when you click on data point, we have associated the data point to logs and traces. So there's a correlation between, it's not a direct correlation. You're going to see a set of logs that are happening around this time frame. So I'm going to click on a log line, and I can see the trace. The log to traces are from Loki to tempo. The trace ID is being sent, so it's easy to correlate this way. As you all know, the exemplars project is gaining steam for us to go between metrics directly to traces. But in this case, we're going from the metrics here to, the metrics to the logs and then to the traces. It is kind of a hack, I would say. We're just using a time range to arrive at these logs. So there may not be an exact match. So I can expand on the trace and spans and notice the response time, how long how much time is spent on each of the spans. But there's nothing interesting here at this moment. All right, the experiment's complete now. Natasha is happy with what she sees because the P95s are sitting somewhere between 3 and 15. Is way less than what Deepak had set. So she's going to hit the dump button. She is at the complete screen. Goes back to the main menu. So Natasha is happy with the results of the experiment that she ran for her cities endpoint. Now she's on to building out the Meet Cities endpoint. The Meet Cities endpoint contains a much more complex query. As I mentioned earlier, it's like taking the pandas data frame and transposing that into rows and columns using crosstab. So here's a quick glance of what the query looks like, which is being executed through SQL Alchemy, an ORM framework for Python. If I were to run the analyze here, you're going to notice that it takes, I'm not going to walk through the plans here, but just to kind of give you an idea, it takes about 317 milliseconds. So Natasha is happy with what she sees, and she is going to go run the put this endpoint to trials again. I'll take this to the trials. Let's switch to the test. Select the cities, click on start, select the level. All right, you see the experiment kicked off at this point. What we've seen here is the meet cities endpoint being put to test. We're soon going to see a little slowing effect. As you notice here, with the reuse, with the little increase in the active reuse, the response, the P95 response times is trying to go up. There's a lot of contention, resource contention happening at this point, which we'll talk about later. All right, you saw the little spike up at this point. Again, the response time shot up from 600 milliseconds to but a little over 4 seconds. And like I said, that's if you are familiar with queuing theory and Mills law, you can see that there is some heavy resource contention going on. And Natasha, the developer, she's starting to get concerned about the performance. And she's already knows that this endpoint code is not going to pass through the trials of chaos. So she's trying to wonder what kind of help she would be needing to make this endpoint a lot more performant. So what she's going to do is she's going to click on one of the log lines. Let's click on one of the log lines here and look at the trace. So I open one of these she opens one of the trace here, expand it. That's interesting that what she saw on her local was the query execution time was close to, on averaging at 350 milliseconds, but here what she's seeing is close to like a second. And she is more curious to click around, and she moves on to another trace, and she is trying to see the same happen here. Well, we'll click around a few more. This is quite interesting. Let's see what's going on here. Well, this is not looking good. This is where she's getting a little confused, right? If the query execution time is less than a second, why is the response taking so long, right? So like I said, if folks are interested to know more about this, I did talk about queuing theory. This is all covered in that topic. It could be, like I said, it could be a dedicated talk just on queuing for another day. But for now, what I want to highlight here is there's resource contention happening, not just within reading from the disk, but also on the threads, the worker pools, on the framework itself. So the experiment's complete at this point. Natasha wants some help. So she uses the annotate feature. And she's going to post an annotation here. So Natasha is a little worried. Now she wants to, based on her observations, she feels like the P95 response time doesn't appear to scale nicely when the load is starting to increase and the average concurrency is continuing to climb as the number of views are starting to increase. That's the cause of her concern. She goes, now it's a note. And there's a speech icon bubble here. I'm going to click on that one. As you notice here, you can tag annotations to the traces. So there's a metadata nicely captured. So you have the trace ID and Natasha's note in here. Natasha's going to exit this. She's going to go back to the main menu. All right, day 3, end of day 3, you see a note at the bottom. There's, if you have chat bots or notifications in place, a TOC, Translate Chaos bot puts a note in your favorite chat system saying the experiment failed. Day 4, debug is going to go look at the Translate Chaos because he saw the note that the experiment failed, and he has some recommendations. So let's see what the recommendations are. So according to debug, he is suggesting that from the outside, what it's looking like is there's a high amount of disputes that are happening with the query, which is causing a significant overhead. There are two things to note here. One is the absence of a secondary index, or at least adding a secondary index on the columns will allow the query to start using the cache or fully utilize the cache instead of going directly to the disk. And the added benefit, which is what ties into Wills' law, is you're eliminating the disk resource contention. We can safely assume that the service load that was causing the retrograde scalability going away. So let's see if that is going to happen with the new change. So Natasha's back again. So she took Deepak's recommendation. She created an index and ran the query. And I wouldn't say to her surprise, but she's happy that the performance gains are 70%. So which is just bring down the query execution time to about 60 milliseconds. So she's going to put the endpoint to test again. Now, as you notice, so she did put the endpoint to test earlier. So you see the two stars at the bottom. She's going to put this to test again. All right, the experiment run is back on. You're going to notice a few things here. Since there was a last run captured in this case for the Meet Cities consumption, overconsumption endpoint, there's a good difference between the P95 latency between the previous run and the current run. Right now, we're looking at 52 to 67, or well, the max duration is 67, but your P95s are somewhat flatlining between 45 and 57. So that's not so bad. As you're seeing, there's not a huge spike, even though the active views are starting to spike. So the index definitely had a good effect on the overall performance of the endpoint, which should make Natasha happy. But she still wants to know, and she's curious to find out what if there's more load on the disk, or or the query execution time, or the Python framework. So she's going to click on a data point, find a log line, and the associated trace. There's still some contention here. Obviously, this could be improved by adjusting the threads or the replicas running on the pod. So there's some room for improvement, but the performance is reasonable at this point. So I'm going to click go on a few more log lines. So the overall response time is 55. It's also relative. So this is the time spent is not a whole lot, 7 milliseconds compared to what was before. So this is good. I mean, what you're seeing here is the system under load is performing really well. The endpoint's performing well. But here's an interesting fact that it did go up to 90, 80-ish. But again, this could be because of some delays in capturing the data. This may not be truly accurate to the second. The experiment's done now. So Natasha wants to know how she did. So it looks like the experiment that she ran, or the test of the experiment she ran, actually passed, and the level 2 has been unlocked. All right, so the endpoint Meet Cities overconsumption passed the trials of chaos, and you got a little notification saying it passed, a little green check. And Deepak, Natasha is thankful Deepak for the little advice, and Annie's also happy because the code's been deployed. Now let me take a moment to talk about what is the architecture behind the demo that we just ran. So as you see here, I'm not big into diagrams, but real quick, you have all the little components running Kubernetes cluster, and it's talking to a K6 cloud running outside the cluster. Well, the point I want to make here is I believe embracing open source community projects like Loki, Tempo, and K6 is the way forward into infrastructure automation. You need to start placing your trust in the community and pay attention to all the wonderful projects and contributions happening around you. Do not fall for the dream of having a single console dashboard for everything. It just doesn't work. Apply the same deployment rigor to observability tooling deployment that you would otherwise apply to your critical code software. Make the shift towards declarative configuration of software and take advantage of the native reconciliation loop of container orchestration systems like Kubernetes. The observability tooling should be simple to deploy and operate as well. As we talked about quite a few things here, the complexity, how we can embrace complexity. We're constantly starting to deal with complex problems. So this solution here is for us to start thinking differently and building a hygiene early on in the design development phases. Thanks for watching my presentation. I hope I conveyed my message on how to embrace complexity.
Hello everyone, my name is Owen Deal. I'm a maintainer on the Loki project and here to talk today about something I'm very excited for, which is the 2.4 release of Loki. It's a big day for us, and as usual, it's been a little bit longer than we'd like between releases, but I'm here today to talk about a bunch of things. This really ranges from making Loki easier to use, all the way to the front end to changing and improving the ways that we interact with Loki from Grafana, as well as introducing some new features along the way. There's going to be 3 of us today, myself, Trevor, who is also on the Loki team, and then Ivana, who is joining us from the Grafana Explore side. So before we kind of jump into it, I'd like to talk about the brief history of Loki. The project is only a few years old, and the first year was spent validating the idea, prototyping features, and ultimately launching the production-ready form on Grafana Cloud. Year 2 was a little bit different. We spent a lot of time focusing on features again, including probably my favorite feature ever in Grafana Loki, which is LogQL v2, which introduced the ability to extract structure from logs, largely championed by Cyril Tavena. And then there are other things like alerting from logs, us really spending a lot of time on performance and parallelization, which allowed us to hit around 40 gigabytes a second query throughput at that time. And then finally, we put everything in the project in object storage, so both our index and our compressed logs. And this was us really doubling down on that as the future. This was a component which came to be known as the BoltDB shipper, which is now the default mode of operation, the single store version of Loki. And that leads us into effectively this year, which has been spent on probably 2 sides. One, closing the gaps for larger, more sophisticated use cases, as well as making Loki easier to use for everyone out there. And there's a couple things in here which are part of the 2.4 release, and I'll talk about them later. But we've largely been able to do this because the community has grown with us. And the growth of the project has given us a lot of confidence that we're doing something right. And so a special thank you to everyone out there who's ever input a LogQL query. And before I hand it off to Trevor, I want us to take a look at what it's like running Loki and Grafana these days. We have many clusters across many different cloud providers, but our single largest one processes ingests about 15 terabytes a day across 4,000 tenants, and then reads back over 1.5 petabytes a week at about 80 gigabytes a second as our top end throughput. And so we've been really focused on scaling Loki and scaling the project, but we also want to make it easier to use for everyone. And so to talk about that, I'm going to hand it off to Trevor, who's going to describe some of our efforts in this area.
Hey everyone, my name is Trevor Whitney. I'm a senior software engineer here at Grafana Labs, and I'm really excited to be here today to talk to you about some improvements we've made to Gel and Loki that will hopefully make it simpler to scale and deploy. Some of you may already be running Loki on Kubernetes, and you may not think it's hard to scale. But as you can see from a sampling of feedback we've gotten from the community, there's been a lot of feedback around the Loki architecture is too complicated. And it's true, the microservices deployment has a lot of boxes in it. People ask questions, how do I scale Loki if I'm not running in microservices? Can Loki work without also deploying console and memcache? And I think these are some very good questions. And hopefully today we answer these with a very clear message about how you can scale Loki, even if you're not working in microservices. And now here at Grafana Labs, we still think microservices are pretty fetch, but we hear you, community. And we've listened to some of the reasons you have, which are very good, such as microservices are complicated. Kubernetes is complicated, and not everyone uses it. And if you don't have a strong orchestration tool like Kubernetes, it makes microservices even harder. Some people just want to kick the tires on Loki. Maybe you're not sure if Loki is the right solution for your organization yet, and you're just trying it out, and you don't want to deploy a whole scalable microservices architecture. Some people are using Loki for hobby projects. And in a lot of cases, compute resources can be cheaper than engineers. And so a solution that is simpler to deploy, simpler to set up, simpler to config, even if it doesn't eke out all possible cycles and bytes of your CPU and memory resources available, sometimes it just makes sense to pay a little extra for those compute resources if it means you can also pay for significantly fewer engineer hours to get the system up and running and configured. So here's a look at some of the things that we have changed. One of our big focuses on making Loki simpler to deploy and scale was to pick better default config values and reduce the overall size of the config. And we've done that. For an environment, so we deployed this to our dev environment, handling similar load as an existing microservices environment. And we were able to deploy it with a configuration file 70% smaller than the existing one. We did that by picking better defaults. We also introduced a common config section where you can provide values that are repeated throughout the config. So maybe your object store configuration is something that you just want to define once and then have it used everywhere. Many of you are probably familiar with this architecture diagram. This is the classic microservices deployment of Loki. And truth to some of that feedback we saw, those GitHub comments earlier, there are a lot of boxes here. This is complicated. And so what we have been able to achieve is to get it down to just 2 boxes. So we have introduced 2 new targets that you can run the Loki binary at. These are what I would call virtual targets, similar to the all target you may be familiar with. And these targets are read and write. You can run the binary on these targets and you can scale those independently. And it only requires 2 different configurations. So this is easier to scale. You can scale just write or scale just read. It's very clear sort of what path you're scaling. This is easier to debug than scaled single binary. So historically, if people didn't want to go full microservices, but they needed an environment they could scale, they would try to run multiple instances of the single binary. And the problem there is that if the box was peaking in memory or peaking in CPU, you didn't know which path necessarily was causing that. And so it was often harder to hone into the exact component that was under stress. In this configuration, a query outage doesn't mean data loss, which is another downside of that scaled single binary approach, because we've split out the reads and the writes. Since there are only 2 boxes to configure here, this doesn't require container orchestration. You can still use Kubernetes to deploy this model and have a simpler overall topology, but you could also do this with Terraform pretty easily on VMs. Finally, this only requires a storage, object storage, and a DNS entry. So you can run console with this for your ring or memcache for your caches, but we've designed this so that you could run this by itself. By default, it'll use the member list and it'll use some in-memory caches to just try and simplify that deployment. So how does this new deployment topology perform? Well, here is a demo that we did. So on the left, we have the microservices environment that was existing, and on the right, we have our simple scalable environment. This graph is showing bytes received by the distributor, and it's just meant to show they're handling similar load. We then took a look at the query latency in the two. We hope just making sure that we didn't see any sort of order of magnitude difference between the two. And we actually saw that the simple scalable environment was performing better. Now, this wasn't a perfectly scientific experiment. The microservices environment has been around for a little bit longer. More people use it. I didn't have a way to control that. I was the only one querying this environment at this time. And we see that the latency is both within an acceptable threshold, relatively similar. But one reason why the latency might have actually been better in the simple scalable environment is this is actually, if we look at the actual bytes being processed, the sort of query throughput bytes, so how many bytes were processed during the query, here we see significantly fewer bytes processed in the simple scalable environment. And one reason for that could be that the simple scalable environment only has 3 ingesters. There's 3 nodes, 3 pods, if you will, on the write path versus 14 on the write path for the microservices. So that's clearly creating many more chunks. There's just a lot more data to process during a query. And so does this mean the simple scalable environment can hold up to the same load as the microservices? Well, no, and it won't scale to that same level. But maybe you don't need an environment that's that robust, that can handle that much throughput. And you just need something simpler. And in that case, the simple scalable deployment model may be a great option. And finally, the config. And this is a benefit that everyone will gain. So whether you're running in microservices or simple scalable deployment, you can benefit from some of these better defaults that we've chosen from this common config that we've introduced. We were able to bring our config file on the microservices side down from 209 lines to 65 lines on the simple scalable. So almost a 70%, just about 69%, 70% improvement in the lines of configs. And then that value will vary sort of from environment to environment based on the limits you need and stuff like that. But across all environments, we expect to see a sizable improvement in the size of the config. So I hope that you've enjoyed my presentation. I hope that you'll give the simple scalable deployment a try. I hope that this alleviates some of those concerns about how do I scale without microservices? Can I deploy Loki in a less complex topology? But now I'm very excited to hand it over to Owen, one of our Loki maintainers.
Thanks, Trevor. Next up, I want to talk about custom retention, which is going to ship as an option in Loki 2.4. Custom retention is the ability to define policies around how long you want to keep data for. And you can do that per tenant, but also at a more granular level per stream within each tenant. And this allows us to make choices like, I want my development teams to have access to logs for a month, but my compliance team should have access to logs for 2 years. Or within each team, I want this team's logs from their development deployments available for a week, their production deployments available for a month, and the audit logs available for a year. And all of these are tremendously helpful as the use for Loki scales across an organization, and you need these fine-grained policies. But it would be problematic if we released that without the ability for targeted deletion as well. And so initially, this helps in things like compliance use cases, such as GDPR's right to be forgotten. But it can also help with cost optimization, or what if we accidentally sent a bunch of data that we don't actually want? We can clean that up much more easily. And all of these kind of combined to make Loki easier and more cost-effective to run across an entire organization. And that's important when you need to scale your Loki use case across a team, a department, the entire org, and you don't want to have to spin up a particularly new cluster for every individual use case or every individual retention policy. So it allows you to gain cost benefits from running everything in a multi-tenanted way, which is how Loki is designed and will continue to be improved. So the next thing I'm going to talk about is a little different, not quite an organizational view, but is a new feature, a spark of inspiration that we stole from Prometheus, actually, called recording rules. Now in Prometheus, these are queries which generate new metrics, and they can generally be used for reasons like pre-computing expensive queries so you don't need to compute them again. And you can still do that in Loki, but Loki certainly brings its own flavor to this. Now Loki allows us to generate metrics from logs and then write them back into a Prometheus compatible backend to expose native Prometheus metrics from those logs. And this can be really helpful in the case that you maybe have logs that you don't have access to the source, that you can't instrument yourself, such as I want to monitor my Nginx processes, but I don't really have the ability to turn the knobs to expose the things that I want. Well, I can now extract this data from log lines and then write them into Prometheus. But there's one reason why I'm really excited to have these, and that's something that we struggled with historically and wanted to be able to monitor in the Grafana Cloud deployments of Loki. And that's per tenant metrics. Now we had a ton of difficulty doing this in Prometheus natively because in Prometheus, metrics are exposed on the replicas or the components themselves. And if you're exposing replicas times the metrics times the number of tenants, that's easily results in what we call a cardinality explosion, an inordinate number of metrics being generated to the point where it's not really feasible for us to use that. Loki allows us to skirt around this problem because a lot of the complexity in these cardinality concerns, a lot of that data is actually embedded in the log lines themselves, which means that we can specify these recording rules here on the left and extract only the data that we need when we need it, and then write those back as Prometheus metrics. And so that's what we're doing here. We're writing them into Prometheus, and then we're reading them into Grafana dashboards. And all of these are per tenant. This is actually a dashboard that we use internally at Grafana to monitor individual tenants' experience in the Grafana Cloud version of Loki. And down here on the bottom is query latencies, particularly how slow are the slowest queries for a tenant. We call these P99s or 99th percentiles, and are very, very difficult to do natively because of the cardinality concerns. But Loki allows us to do this in a way that's a little more attractive. And so whether you're using recording rules to generate these things that you'd have cardinality concerns with, or if it's for applications that you don't control the instrumentation or the source of, or if you just want to pre-compute expensive queries, I'm very excited that recording rules are released as GA in 2.4. So finally, this is the last thing I'll talk about today, and is definitely my favorite, but I am a little biased. This is also the probably most upvoted issue in the history of the project, and that's support for out-of-order logs, or dropping Loki's ordering constraint. And so for those not familiar, a little bit of background: before 2.4, Loki had required that logs came in increasing timestamp order. And this was generally okay. This generally worked for most of our use cases. And Loki is built to be unopinionated in a schema list. And we want to be able to accept logs from any team, from any programming language, in any environment, and then sent across through any agent. It shouldn't matter. Loki should be able to accept this and then serve that data in a way that is usable and actionable. But the ordering constraint ran afoul of a couple of legitimate use cases, particularly ones that either weren't aware of the constraint or that had difficulty ensuring the order. And that could be for a number of reasons, things like clock skew or problems in processing pipelines that made it have just a little bit of jitter. And so we found that the vast majority of this was off by a second or two. It was basically just jitter. And so with Loki 2.4, by default, we'll have support for out-of-order logs, which means that you shouldn't have to change anything. And if you were experiencing this before, this should just work. Now, there is a limit to this, a sort of validity window, but that's configurable and up to the administrator to define. And we'll continue to make Loki easier to use, more of a turnkey solution for people so that we don't have to expose internals when we don't need to. But that work doesn't stop at the boundary of our open source repository. And so next up, I'm excited to have Ivana take over and talk about all of the work that's gone into the Grafana side to make Loki easier and more intuitive to use.
Hello, everyone. My name is Ivana. I am a software engineer at Grafana, and I'm truly excited and honored to be here today and to have a chance to talk about new features and improvements for Loki in Grafana. And there is a lot of them, so let's just jump right into this. As you can see from the title of this slide, I'm going to be talking about features and enhancements that are part of Grafana 8 releases. And I highly recommend you to check out the incoming 8.3 release that basically gets them all. In this slide, I have tried to list as many features as I could comfortably fit here. So you can read through them. Maybe you will find something that you were missing or something that you were looking for. But in this talk, I would like to highlight and demo only a couple of these. And I would like to actually focus on those features that are your favorites, at least based on GitHub comments and upvotes. So let's see what they are. So we are starting with improved templating, and I'm going to move directly into my Grafana dashboard to show you what is new. Improved and more robust templating was actually one of the most upvoted feature requests we've had for Loki in a while. So it's clear that you, our users, are using templating to build dynamic and interactive dashboards, and that this is something that is important for you. That's the reason why we have added a new type of templating query that returns the values for your selected label and log stream. So let me show you how it works and how you can create one. So we are moving to the list of variables. We have here 3 variables. First one is label name that returns the labels that are in your Loki instance for your selected time range. The second one is label value that returns list of values for your selected label. As you can see here, we are also using nested templating, which means that you can change the label on the fly and get values for your selected label. The last query is the new one, and it has very similar syntax to the label value. We are also getting the values for our selected label, which is in this case namespace, but we are also specifying the log stream. And as you can see here, we are again using the nested templating, and therefore we can really create dynamic dashboards. And I will show you how they look and how it works. So here we have a list of all our labels from which we have chosen cluster. We have here all clusters. And here we have a list of values for namespace label for the log stream that contains this label value pair. If we change it, for example, to this one, our option changes as well. If we go back, we will again get these 3 options, which is Cortex, Loki, and Tempo. If you were looking closely, you could see that every time I have chosen a value from the dropdown, all our dashboards reloaded, and basically queries that contains that variables were used. So that's the way how you can build really, really dynamic dashboards. And if you would like to see and play with a great example of dynamic dashboard, I highly recommend you to check out our play site. We have quite recently added a Loki data source, and you can find there also this dashboard. So if you would like an inspiration for your dashboards, definitely check it out. So moving on to logs pagination and explore, and I am going to move here. So we've been hearing that you are quite often hitting line limit, and we are also quite often hitting line limit before we reach end of our or your time range. So in this case, our time range is 1 hour, but we see less than 2 minutes of our logs because we've hit our line limit of 1,000 logs. And we were looking for a way how we can simply, but also effectively see next 1, 2, 3, 4,000 of logs. And that's the reason why we have introduced logs pagination that you can see on the right side right here. And whenever you are searching for a log and you don't find it within your first, let's say 1,000 lines, you can click on the older logs button and new query with the updated time range is issued. We can click on it a couple times. And as you can see, each of our pages contain start of the time range and the timestamp of our last received log. If you would like to go back, you can always click on the previous page, and the query is not issued because we have caching. So we are caching last 5 results from last 5 pages. And therefore, if you've already issued a query, we just reload those results and you don't have to unnecessarily run the same query over and over again. So I think that's it for the logs pagination. And we can move to the full range log volume, which is definitely the most upvoted and wanted feature we've seen for Loki. And I'm happy to say that it's actually going to be part of 8.3 release. And I'm very excited for you to try it out. So let me show how it works. And let's go back to the Explorer. So whenever you run a query, for example, this, in my case, for which you would like to see log volume, you can just click on the load volume button. The query for log volume is issued, and you can see it right here. So we have time range last 1 hour, and we can see here that the graph is also for 1 hour. You can use this graph to zoom in. And also the logs are reloaded, and we can see the logs that are within this time span. If you want to reload log volume, you can do it and find, for example, error or warnings that you are searching for. And how do we know which logs are errors and warnings? That's the reason is that in our log lines, we actually have this information. So our log lines are in log format, but you can use any format that you use. And we use log format parser that basically changes this key value pair into the label. And that label can be used by the graph to find out what is the log level that we are seeing. And that's actually everything from me and everything from us. We hope that you all liked our talks. And if you have any questions, we are actually having a Q&A right now. So definitely join and see you there.
Hi, everyone. Oh, I don't know if they can hear us yet.
Yep, we're live. Hey, everyone. I think Trevor's going to ask some questions, and we're going to do our best to answer.
All right. So there was a question. Sorry, I must have missed a step. What is the difference between a microservices deployment and the simple scalable deployment? Can I just use the former? Great question. So the simple scalable deployment is an attempt to have less targets. So in a full microservices deployment, you're likely splitting out every single component. So your distributors are running on their own, your couriers are running on their own, your ingesters are running on their own. The simple scalable deployment allows you to just run two targets. So you either run read or write, and then you can scale those two paths independently. And it handles all of the dealings of sort of bringing up your couriers, bringing up your query schedulers, connecting the query schedulers so they can shard the query, and bringing up your distributors in the right path and your ingesters and connecting all of that. So you have many fewer targets to run. And what's great about that is if you're running on like VMs or bare metal, you sort of only have two configurations that you need to handle. Let's see. There's a question of if recording rules will be available to configure in any way in Grafana Cloud. Owen, do you want to handle that one?
Yeah, they are. Right now, you can do this by API, by CLI. There's one called Cortex tool, and I believe we can also do it via the new unified alerting interface on Grafana, which is available after 8.03. I'm going to defer on that one. But yes, the idea is that should be available to set in Grafana Cloud via a number of means.
Awesome. Does Loki 2.4 still support the Bolt DB shipper? I'm pretty sure it does.
Yeah. The series of rebranding, we're trying to figure out the best way to describe that. Now you can really run Loki with only an object storage backend, and that's kind of the first class way to do things moving forward. Historically, if you look at the project, when we initially launched, we had the ability to store what we call our chunks, which is our compressed logs, compressed in object storage somewhere. But then we would also run a dedicated index, think out of something like DynamoDB or Bigtable from in Google Cloud, or self-hosted Cassandra, that sort of thing. And then eventually we migrated away from using this secondary index store, because that both was a costly thing to run in terms of like operational complexity, but also in terms of monetary cost as well. And so we moved everything into backend object storage, and then build components out to be able to function on top of that. And we've been putting a lot of work into that for probably about a year and a half now. I think so. And that's definitely the way moving forward. So the new simple scalable deployment model is based entirely off of the Bolt DB shipper component.
I have another question here. I just noticed the release blog for 2.4, and it talks about horizontal scaling of the single binary. Can you tell me how that works? I think I could take that one. So a lot of the work that we did to support the simple scalable deployment, the single binary also benefits from that. So we have a ring for the compactor. So the compactor can intelligently run on just one instance, and so you don't have conflicts there. We have a ring for the query scheduler. So multiple single binaries, this query scheduler can cluster together to provide one sort of big queue for your queries to split. Let's see, are there any other ways that you can think of that we have made the single binary more scalable, or did I get them all?
I think you did a good job.
All right. Thanks, Owen. Let's see. So there's a question about performance. If there is a way to improve any performance, particularly for queries over a longer period, say 7 days, with multiple string filters. Owen?
Sure. Yeah. This is a really large topic, but we generally see people starting to complain about performance after they've been experimenting around with running Loki as a single binary. Think how you would run something like Prometheus, where you'd have one instance, and that would be ingesting logs from across your whatever your deployment topology looks like. You know, if you're using Kubernetes or VMs or what have you, and that will do well up until a point, but Loki largely tries to parallelize its queries. And it does this by just throwing generally cheap compute power at it. So all of the components are internally built to be kind of scalable. And while we run Grafana Cloud in a what we call microservices deployment, where we have different banks of individual components that can kind of scale independently, now we have the ability to get a lot of these benefits running in this simple scalable deployment mode, where you can say, oh, I want more query throughput. Well, now I can just add a couple more read nodes and then scale that accordingly. And it should largely take care of a lot of the, a lot of the extra work for us. And the idea here is that we can then make it so you don't really need a PhD in clusterology to be able to run Loki in a performant way. But we definitely see people starting to complain after using the single binary, and then when they're starting to get into more productionized use cases. So my advice there would be start to choose one of the deployment modes, microservices if you're really adventurous. But for most people, I would definitely suggest use the new simple scalable mode and scale out that way. The one other thing that is important to mention is historically in the what we call the single binary deployment, when you're just running one instance of Loki, that couldn't really benefit from any query parallelization techniques. And now we've changed a couple things internally so it can actually utilize this. And so if you have, for instance, more CPU cores available, you should be able to get higher throughputs with the 2.4.1 release than you would prior.
Awesome. Thanks, Owen. Owen, would you mind saying a couple of things about Azure support and what modes we can run Loki in to run on Azure?
Sure. We've been running, we actually have an Azure-based cluster of Loki live in Grafana Cloud for maybe 2 years now, a year and a half. So you can use the Azure Blob Storage backend. And I think that will largely continue to work. What I'm guessing is maybe we have some documentation gaps there that we need to fix. But that's definitely something you can do today that you've been able to do for a while.
Let's see. Is the label for the load volume customizable?
So I think that's a question for me, and currently it is not, but we are definitely open to all feature requests and feedback. So if this would be helpful for you, go and create issue or feature request in a GitHub, and we will definitely consider.
All right, we are getting a signal to wrap up shortly.
All right. Well, one question I want to quickly answer then. Where's Ed? Ed is in the public Slack channel of ObservabilityCon. So if you have any more questions for us, we'll be watching that for a little bit after this, and Ed's there also. So that is a great place to continue this conversation. Sorry for the questions that we didn't get a chance to answer.
Yeah, and if you have any more questions, please drop by in public Slack, and we'll be available. Take care.
Bye, everyone.
Hi everyone, welcome to the evolution of monitoring at Nutanix, how we combine the best of a legacy system with Kubernetes, Prometheus, and Grafana. I'm Rohit Subramaniam, a software engineer at Nutanix. I belong to a team which builds a Kubernetes-based microservice platform for internal consumption, as well as a managed Kubernetes product for our customers. Among building and maintaining our monitoring pipeline, I also work on other things. Today I'm going to speak about how how monitoring is evolved at Nutanix as we've adopted microservice architecture. So I'm going to begin with how service architecture has evolved at Nutanix with the adoption of containers. As a result, how our monitoring systems have evolved. Then I'm going to introduce our Prometheus stack, and Nutanix Prism Alerts is our monitoring system for our traditional services. And then I'm going to talk about how we combined the best of both Prometheus and Nutanix Prism Alerts. And then I'm going to talk about use case of Grafana. So in a survey conducted by CNCF in 2020, which is the Cloud Native Computing Foundation, 92% of the respondents said that they're using containers in production, which is like an extraordinary increase of 300% from the first time the survey was conducted in 2016. At that time, 23% of the respondents said they're using containers in production. In 2019, it was 84%, and in 2018, it was 73%. So everyone is rapidly adopting containers, and so we are also doing the same with Nutanix to increase the rate of innovation and like boost the agility and speed. And as Nutanix has gone beyond delivering hyper-converged infrastructure to our customers to delivering software-defined enterprise cloud, running applications at any scale, the service architecture of Nutanix services has evolved from running in virtualized environments to container applications in microservices environment. To enable this, Nutanix has built an internal product called the Microservices Platform, MSP in short, which is a Kubernetes-based microservice platform to run our internal services as microservices. And it basically involves the Kubernetes platform, as well as some add-on services like logging, monitoring, identity management, load balancing, which are leveraged by services running on them. Nutanix Objects was one of our first core products to adopt the microservice architecture, and that has been a cornerstone for many other applications onboarding onto our microservices platform. Our microsegmentation product called Nutanix Flow also runs on the MSP platform, as well as some parts of our Prism management console. Having spoken about transformation into containers, I want to briefly touch upon the challenges of container monitoring, and I want to contrast it with traditional monitoring. Despite the popularity of containers for modern applications, like we can see in this chart, this was again from the CNCF 2020 survey, 27% of the respondents cited monitoring as one of the top challenges for them to adopt containers. Adopting a monitoring system comes with its sort of unique set of challenges compared to a traditional monitoring system. And those challenges are the following. That containers are ephemeral, they can be quickly provisioned and as just quickly destroyed. This behavior is one of the primary advantages of containers, but also it makes it difficult for monitoring systems to track these changes, especially in a complex system with high churn. And the second challenge is containers share resources like memory and CPU are shared across one or more hosts, making it more difficult to monitor resource consumption on the physical host. So which makes it hard for a user to get a good indication of container performance or application health. And the third one is insufficient tooling. Traditional monitoring platforms, even though well suited for virtualized environments, may not provide sufficient tooling or sufficient insight into metrics, logs, and traces needed to monitor and troubleshoot microservices. So one can't just adopt like a monitoring system built for traditional services to container or microservices environment. And a good monitoring system for microservices needs to provide an overview of your entire application, as well as sort of relevant information on each component. And things like how easy it is to add instrumentation into your code and how easy it is to configure alerts become very important. Having said that, this is what we have adopted as our monitoring stack in the microservices platform. So we basically use Kube Prometheus, which is an open source project on GitHub. It's basically a package of several components to operate an end-to-end Kubernetes cluster monitoring, with Prometheus being managed by Prometheus operator. And it includes other components like Prometheus Alert Manager, Node Exporter, Kube State Metrics, and Grafana for visualization. As our services have evolved in Nutanix, so have our monitoring system. So like we just saw, the microservice platform uses Prometheus, whereas our traditional VM-based services uses an in-house built monitoring and alerting system that we've called Prism Alerts. So over the past few years, the Prism Ops team within Nutanix has built some great features within this product that our customers love. And, it brings in a lot of simplicity and automation for an IT operator, being our customer. And then I'm going to talk about, how these two disparate monitoring system has sort of fragmented, because we have Prometheus Alerts, which is very different from what we've built in-house with Prism Alerts. And then I'm going to, say how we solved this, how we were able to bridge Prometheus with our Prism Alert Manager. So I want to briefly touch upon why we still, love Prism Alert Manager and all the advanced features it brings to our customers. So this is like a screen grab from our Prism Alerts page on Prism. Prism is our management console. So customers are able to log into the management console Prism and go to the alerts page. And here you can see that, it has various options. You have alerts displayed, and then you even have clickable entities on these alerts. So all these text in blue are clickable entities. So if you click on them, say, for example, an alert has a source entity. The source entity can be a cluster, can be a VM. Once you click on that, it gives you an overview of that entity. So a customer can understand how an alert is affecting a particular entity and understand the holistic view of its health. And it has various other advanced features like grouping and filtering, and you can perform actions on top of each alert, things like email forwarding, SNMP trap notifications, and you can even automate actions based on alert. So you can have a playbook with certain actions being performed whenever an alert is triggered. So let's compare and contrast that with the Alert Manager UI, which is pretty basic. So it has all the basic features that you expect from an Alert Manager system, like resolving. I mean, you can't even manually resolve the alerts in Alert Manager. It has things like silencing an alert, snoozing an alert. I mean, it's the same thing, and viewing basic information about the alert. Whereas over the past few years, we've built some great features within Prism Alerts, like things like viewing alerts history, and email. Even the email forwarding has, you can basically have complex rules where you're able to filter on subjects and only forward specific emails. And it also provides an UI for our customers to sort of customize each alert policy based on their need. So, a customer can log into Prism, view all the alert policies that's been configured on their cluster, and can also modify certain thresholds. So if we were to do that within Prometheus, of course, Prometheus also allows that, but again, it means that we have to deal with YAMLs. So they don't have the UI integration. So instead of reinventing the wheel with building a UI for Alert Manager with all these advanced features, the objective was to integrate Prometheus with Prism, right? And, that way we can combine the best of both worlds. So this is how, we were able to do that. So if you see on this screen grab, you'll see our Prism alerts, which can typically fire on a Nutanix cluster. And you'll also see the one that I've highlighted below, which is coming from our MSP platform or our microservices platform, and they're typical Kubernetes alerts that can fire. So I'm going to next talk about how we did that. So we basically did that by building a system called as Alerts Broker, which is an adapter between Prometheus alerts and Prism alerts. So Prism, Prometheus alert is basically a schema-less alert, right? It's a simple PQL query that a user has to configure. And if that query returns vectors for a certain threshold, it fires an alert or an alert becomes active. So it's as simple as writing a PQL expression. Whereas Prism doesn't support schema-less alerts because Prism has such advanced features of being able to click on alerts, associating an alert with entities, and all of these advanced features. Every alert policy or an alert definition has to have a certain set of rich attributes that defines that particular alert. So essentially, an alert has to be defined first, and then an instance of that alert can be raised. So Prism provides like a schema definition endpoint and an alert notify endpoint, which is used to first create the schema of the alert and then create an instance of that alert. So the alerts broker is we made use of the webhook in Alert Manager, and the webhook, every time it receives alerts from Prometheus, it forwards the list of all those alerts to its configured webhook. And we configured alerts broker to be running as that webhook. And the functionality of alerts broker is twofold. It basically, the main job of the alerts broker is to transform all the alerts from Prometheus to Prism. But like I just said, for Prism, an alert has to be first defined, and then you can raise an instance of that alert. So how do we basically give all the information about a Prometheus alert to Prism, right? So the way we did that is through annotations. So if one were to use the Prometheus operator project, it basically is a Kubernetes native way of deploying and managing Kubernetes or managing Prometheus. The way you define rules, if you were to use Prometheus operator, is you have to create an instance of a custom resource called Prometheus rule. And here on the screen grab, I have shown a simple example of a single alert being defined, right? So here, the alert is to catch kube pod crash looping. And typically, the ones that you would define are the ones that are not highlighted, right? So you have a message of the alert, then you have the PQL expression, and then you have a threshold parameter, and then you have severity. Whereas Prism requires, a Prism alert requires some extra information, which enables all those advanced features. And that we had to somehow embed within the Prometheus rule object. The way we did that is have them as annotations. So these are all the parameters that are, or the schema attributes that are needed to define this particular alert for Prism. So all of them are added as annotations. And going back to my previous slide, so the alerts broker actually registers a watch on the Prometheus rule custom resource. So it gets a callback every time this object is created, updated, or deleted. And once it gets the callback, it's able to go through the entire object, then determine the list of all the alerts, read through all the annotations, get all the attributes needed to call the schema definition API on Prism, and calls the schema definition API to create that alert on Prism. And then whenever it receives a notification from Alert Manager through the Alert Manager webhook with the list of all the alerts that are currently active, it is now able to call the Prism Notify API, which is used to raise alerts for Prism. Now that we've already defined the schema on Prism, we are able to easily also send the alert instance. So this way, all Prometheus alerts are seamlessly transformed into Prism. So almost in real time, every time an alert fires on Prometheus, our user is able to instantly see that on Prism. And also they're able to take advantages of all the advanced features that Prism provides, like alerts history, manually resolving alerts, setting up custom actions on alerts, clickable entities in alerts, etc. So this is how we were able to combine the best of Prometheus, being its simplicity, the way you define alert is like a simple PQL expression in a YAML, and we're also able to take advantage of all the advanced features that Prism provides. And finally, I want to end with talking about how we use Grafana in the microservices platform. So these are all the dashboards that we've installed in our deployment. And one of the dashboards that we heavily use is the pod resource dashboard. So the microservices platform actually uses user VMs as its node. So essentially, we are eating into customer CPU and memory resources. So we want to make sure that our pods are rightly sized so that we don't consume too much resources of our users. But at the same time, we don't want to starve any of our pods by giving them fewer resources than they, or lesser resources than they need. So we use this dashboard every time we make enhancements or new features in our components. We come back and we check how our pods are performing in terms of CPU and memory, and if the resource requests and limits have been rightly set, and if we can adjust them accordingly, like either increase or decrease them based on how they're performing. That sort of gives us confidence that we are sizing our pods right. So Grafana is something that we heavily depend on in order to visualize all the metrics that we keep gathering in our longevity clusters over time. That's about it. Thank you. Hey everyone, thanks for tuning in. I have an anonymous question here. The question is, do you see yourself ever turning off your old monitoring service, or will it be hybrid going forward? How do your customers view the value of both? So to answer the first part of the question, near and midterm, we will be probably using like a hybrid model, where our microservices will use Prometheus being sort of the de facto monitoring solution on a Kubernetes cluster, whereas our traditional services will continue to use them. But of course, the eventual goal is for all our services to transform to microservices architecture. And with that happening, maybe all the backend components, backend monitoring components in the future can be run by Prometheus, whereas we can provide the user interfacing part with what we've built in-house. To answer the second part, how do your customers view the value of both? Ideally, our customers should remain oblivious of what monitoring system we're using in the backend. So I think what customers really appreciate is the simplicity with which they can operate a Nutanix cluster today. And if they're able to do that on Prism, on the portal, I think that is what they love about Nutanix product and Nutanix Prism. So we ideally do not want customers to be aware of the fact that the monitoring system is being run by Prometheus or something that we built in-house. So I have another question. Excuse me. How did your debugging process change with this new setup? I think to answer this question, I think in general, the debugging process has been like how one would adapt to a microservice environment. I would say it has become much more easier with all the tooling that we have built around our microservices platform. And in general, with so many great open source tools available, we've been able to adopt that for example, for our logging, monitoring, and other services. But the beauty is we've been able to integrate that with all the traditional sort of Nutanix diagnostic tools. So for customers or for our SREs, it's as good as our old traditional systems, and we continue to debug them the same way.
Thanks for joining us today. This session is going to be going over deploying a centralized network agnostic Prometheus experience. I'm Ted Cordery. I'm a senior product manager here at Unity in the engineering services group. And joining me today, and the true star of the show, Taylor Much, who's a senior software engineer in the same engineering services group. So just a quick agenda of what we're going to be covering today. We'll be talking about who we are as Unity. We'll then be going into the problem we've got faced in our scale as we grew as a company and kind of the objective we set out to solve. We'll dive into the solution, probably the real reason you're here today, as well as give you some of the learnings that we found out in developing this solution. And then we'll wrap it up with a little bit of future of where we're taking this. So who is Unity? Unity's been around since 2004. Today, we're a company of 5,000 employees, and we have about 2.7 billion users who use our technology, whether that's consuming content that is created with our editor or interact with one of the many operating services that we provide our customers. So we're here to talk about Prometheus. First, want to call out that Prometheus as an open source technology is great. We had a perfectly fine implementation for the infrastructure that we had a few years ago. We've grown quite a bit. I think we've almost doubled in the last 2 years. So back then we didn't really have an infrastructure that really needed more than what was capable with the basic implementation of Prometheus open source. Today, we've actually, with our size, grown to having over 200 GKE clusters. So quite a large footprint. And as well as those clusters being around the size of 50 nodes per cluster and at least 20 pods per node. So a decent amount of infrastructure is what we've had to scale to over the past couple of years. So as I mentioned back a few years ago, we were chugging along just fine. And then we finally came into some issues. Our primary issue with our initial implementation of Prometheus was around private networking. We had a connectivity issue to where our cloud hosting provider could only allow us to scale to such a certain size. So the limitation there was the number of VPC peering limits. We were maxed out at 25 back then. That has since subsided, but our existing architecture was very much reliant on that private network connectivity. So being able to hit the endpoints wherever we needed to route. This also led to other side problems, mainly being fragmentation of our metric solutions, which led to our SRE teams and teams across Unity not knowing when we had problems with our infrastructure, if it was isolated to just one team or something that was a outage across our entire infrastructure landscape. So we decided to go out and try to solve this problem, being able to fit the needs of our scale, get around our private connectivity issue with the VPC connectivity limits, and also wanted to provide at the same time a centralized pane of glass for Unity as a whole. So anyone could go see if we were having issues, if that issue was isolated to just their part of the infrastructure or the infrastructure as a whole. So we set out to continue evolving our existing infrastructure. We here at Unity, we very much subscribe to using open source technologies. Not only is it a great opportunity to stay cloud agnostic, it is also a great opportunity to have our engineers learn common tool sets that they will be able to use in their career. And to do so, we ended up using other technologies to solve this problem. Some of those are Prometheus Operator, Vault, and Cert Manager, which Taylor will go into much later. And we wanted to be able to provide an easy transition path for our teams who were using the existing implementation, which led to another kind of smaller problem where, we can't call this the new Prometheus or Prometheus 2.0. It can become very confusing. So we decided to give this new solution that we were going to come up with a name, and that name was Cronus. So a little bit about Cronus, like how did we come up with that name? So Prometheus, we really like the name Prometheus. We understood it was, part of the Greek mythology naming convention. So we decided to stay in that same thread. And since this was going to be handling the large scale that we wanted to handle, we felt, we got to go a little bit higher than just, some Titan in Greek mythology. So we decided to go to the top. As you can see here, Cronus is kind of the father of the Titans and leads them all. And we've just felt it was a nice way to associate kind of what we were trying to set out with this solution. So next, I'm going to hand it over to Taylor, who's actually going to give you kind of more technical deep dive on how Cronus was put all together.
Thanks, Ted. So to kind of get into that, in order to achieve that top-down global view of our infrastructure that Ted was talking about in a network agnostic way, we first needed to conceptually break down what kinds of environments we had in our infrastructure. Since we use Kubernetes heavily in our infrastructure in Unity, this meant that we needed to logically group our clusters together into distinct environments that we wanted to monitor. So what we did was give these clusters names, calling them either observer clusters or client clusters. Observers run on their own network containing a Thanos query. For those who are not familiar with Thanos, you can layer Thanos queries on top of each other to perform query fanout and to connect different Thanos query endpoints within your infrastructure. This is one of the key features that allows us at Unity to have the flexibility that we needed in the Cronus architecture. Clients also run a Thanos query, which is then connected to that cluster's Prometheus endpoint, therefore achieving that top-down query architecture we had in our previous architecture. These clients are therefore monitored by one of our observer clusters, which means that these observers are where we have users at Unity run their Prometheus queries. Ultimately, what this means is that the observers become our individual Prometheus data sources in Grafana. And since we run a lot of these Kubernetes clusters at Unity, we needed some way to logically organize them within our Grafana by environment. So whenever we needed to stand up a new environment, we added a new observer into our infrastructure and a new Prometheus data source in Grafana. This allows us to have a nice clean separation for data that's collected in each of these environments. For a concrete example, at Unity, we commonly have a separation of data from what is in a staging environment versus a production environment. And we may also even have separate environments for dev and QA, or even our own internal development and testing environments for Cronus itself. So now to talk a little bit about clients, the clients really have the easy part of this architecture. They collect Prometheus metrics. However, in fact, each client in the Cronus architecture is its own self-contained Prometheus and Thanos implementation. At Unity, we've found this setup to be really useful because it means that these metrics are collected and stored locally by each cluster. When clusters come online or go away, we can just attach and detach those clusters as needed from the overall system. This also solves a common problem that we had experienced at Unity, where we would sometimes have individual Prometheus deployments become overloaded from high cardinality. Whenever this occurred, we could just remove that cluster from the observer, go solve whatever problem was happening with Prometheus in that cluster, and then add it back into the overall system when it had returned to a healthy state. Overall, by having these isolated Prometheus setups in each client environment, we enable teams at Unity to become fully autonomous at deploying Prometheus into their environments, achieving a self-service method for deploying our metrics system at Unity. It also gave our developers some familiarity with how Prometheus metrics were being collected in their environment by leveraging Prometheus operator. But we haven't yet solved how an observer actually connects with cluster and query its metrics in a secure way. To solve that, we needed to solve the network security problem. In Thanos, it uses gRPC to connect to each endpoint to retrieve data for Prometheus queries. But since we are running Thanos across untrusted networking environments, we knew that we needed to secure these gRPC connections into each client's Thanos query from the observer's Thanos query. Additionally, given our requirement of being provider agnostic, we knew that the only real option we had was leveraging mutual TLS. For those not familiar with mutual TLS, I'm going to skip over the specifics of how it works and focus more on how we implemented a mutual TLS solution. It's worth noting that at the time, before we started working on Cronus, we didn't know that GCP HTTPS load balancers didn't support mutual TLS. So to solve that specific problem, we decided that we needed to provide an ingress solution in our client manifest that would get distributed to teams. We chose Nginx simply because we were familiar with it, but any gRPC compatible ingress that also supports mutual TLS is also completely fine. So knowing that we needed to implement a mutual TLS solution, we were then presented with the next challenge, providing a private key infrastructure, or PKI, that would be simple enough for us to operate, but also flexible enough for us to use with confidence. And also, we didn't want to implement yet another authentication layer. So when building a mutual TLS environment, you needed to provide a private trusted certificate authority, which can build out a web of trust for your clients. Also, because it's private, you need to provide an authentication layer to enable you to request TLS certificates in a secure way. Fortunately, at Unity, we were already heavy users of HashiCorp Vault for secrets management. We knew that it could support a PKI system, and so we decided to include it as a part of our observer architecture. This means that each observer environment now serves two roles: query aggregation and issuing TLS certificates. But now we needed to solve yet another problem, which was how to distribute those TLS certificates. For those who are familiar with PKIs and managing TLS certificates, this is probably one of the most frustrating and tedious parts about running a private PKI. Fortunately for us at Unity, we were also already familiar with JetStack Cert Manager. It's a fantastic open source tool that teams can leverage for automating TLS certificate requests and installation into Kubernetes clusters. And it natively supports Vault. What this means for the Cronus architecture is that we set up a Vault cluster within our observer environment and configure cert managers in both the observer and client environments to request certificates from it. In the observer environment, we request a client certificate from Vault and configure Thanos to use the client certificate as part of its startup configuration. In the client environment, we request server-side certificates that get installed into our ingress, in this case, Nginx, to verify the client certificate coming from Thanos. This means that every time the observer's Thanos query makes a connection to the client's Thanos query, it will present the client certificate to Nginx, and Nginx will use its certificate chain to verify this client certificate. And since both certificates are coming from the same vault, our same PKI, they will be able to trust each other and allow Thanos to access the client cluster's metrics. Therefore, with this certificate automation in place, we could completely automate our mutual TLS solution within our Cronus architecture. These were the key features which enabled us to realize and prove out this architecture and make it extensible at Unity. So how do we actually deploy Cronus? At Unity, we utilize Helm charts to package these components and distribute them internally to our teams for deployment. This means that the client and observer environments can be built out separately and then integrated together in collaboration with SRE and our service teams. At Unity, we build on top of the community-maintained Helm charts for Kube Prometheus Stack and Thanos, and the HashiCorp-maintained Vault Helm chart. We also have teams deploy Cert Manager as a prerequisite into all of their clusters, since it can be also used for issuing TLS certificates from other vendors, other than being used in the Cronus architecture. With all that said, this is what the overall Cronus architecture looks like. We have Grafana configured to access Thanos query in the observer environment, Vault installed into the observer environment, Cert Manager in both the observer and client environments requesting certificates from that Vault, and of course, we have Thanos and Prometheus in each of our client deployments. And thus, whenever someone runs a Prometheus query in a Grafana dashboard using a data source backed by Cronus, the query will be handled by Thanos running in the observer environment, which will make secured gRPC connections to Thanos running in each of the client clusters connected to the observer environment. We learned a lot when building out this architecture at Unity, particularly that running a PKI can be hard, even when using something like Vault. We also learned that tuning Prometheus workloads in each cluster can be challenging. One really nice thing we learned was that by isolating each cluster as its own metric system, we were able to avoid some common pitfalls with Prometheus, such as bad clients creating a lot of metrics. If this happened, we could just remove that cluster from the system until it was no longer causing a problem. We also learned a lot about the benefits of a full pull model, but there were still some challenges with implementing this for some teams. So investing into a small amount of remote write is likely one of the areas that we will be pursuing in the future. To talk a little bit more about the future, I'll pass things back over to Ted.
Thanks, Taylor. And as you mentioned, we are for sure looking at implementing potentially a remote write first feature for some of our teams. Because as we work with our teams, we obviously get feedback from them, what works, what doesn't work. And that was the number one request so far, was how can we implement potentially Cortex into our architecture. We also are considering actually expanding and having the teams who operate outside of our main core infrastructure in GCP this tool. So actually designing something versus operating something are two very different things. So as we go out and actually support teams implementing Cronus into AWS or private data centers or elsewhere, we'll continue to collect feedback and feature functions that we need to provide for them to be able to meet their needs. Then lastly, the size of a company that we are, I'm sure as you all have the same problem, is actually getting adoption and communication out to everyone to understand that this is a tool now available. So we'll continue to push and inform our customer base, the internal engineering teams, about Cronus, the very cool aspects of it, and why they should be using it, in hopes that it will actually give us an actual centralized single pane for our entire Prometheus metrics for our infrastructure. So just want to take time and thank you all for being here. And if you have any questions or would like to connect with us, both Taylor and I are on LinkedIn. Please feel free to reach out, connect, and we hope to hear from you. Thanks for coming. Hello, welcome to the Q&A session. We have a few questions in here, so please feel free to ask more. We're here live to answer them. I guess the first one that came off and on the last topic for adoption around a barrier across Unity, what tips would we give? I would say the biggest tip is to start somewhere. Get it out into your customers' hands, understand what works and what doesn't work, and then take that back and be able to iterate and improve on. So that's something that we firmly believe and move towards as well. Taylor, I have a question for you. Samuel asks, do you have issues with partial responses due to downstream Prometheus pods being unreachable?
That's a good question. Sometimes we can come across that. That is one of the things where I think we're, for teams that need that really strong consistency with their queries, something like remote write can help with that, to make sure that if your queries are latency sensitive, something remote write could help there. In the case of Cronus, the Cronus architecture, being able to have the ability to query all of our clusters at the same time really helps with that. But for partial responses, we do run into that. That is something that we've received some feedback on, and being able to retry queries is something that Prometheus has a really good experience with as well. So that's a good question.
Great. Well, those were all the questions. So please throw questions in there, but I'll ask you one question, Taylor. I guess if you were someone listening to this presentation, what's the one thing that you'd want to make sure got across, or that you'd want to take away from it?
Yeah, I think the one thing I would say to take away from it is Prometheus is a really flexible tool. And at Unity, we have really deep experience using Thanos, but there's a ton of really great, there's a great community around Prometheus itself. And there's always new and exciting ways to solve a lot of these problems. Like partial response, the question that was asked previously, being able to make sure that we're doing things in a stable, reliable way for all of our customers is, if we're not providing that, then we have some work to do. But I think the other takeaway that I would take from this presentation is being able to implement a secure Prometheus experience can be, it's not as hard as it might look. We kind of talk about these things. So the mutual TLS, being able to implement that, utilizing Vault or a PKI can be really straightforward if you are struggling with security. We're available on LinkedIn. So if you have any more questions, feel free to reach out to Ted and I.
Yeah, thanks everyone. And there's no other questions. And yeah, I hope you all enjoy the rest of the conference.
Hi there, my name is Travis Patterson. I'm a software engineer here at Grafana Labs, and thanks for coming to our talk. As you know, Grafana is meant to help you pull together observability data from tons of different sources and use it to keep your services healthy. In this talk, we'll introduce new Grafana plugins and capabilities that are pulling data together all the way up and down the observability stack, and also across the software development lifecycle. We'll talk about an entirely new way to create time series data, new data source plugins, and new ways to explore logs, traces, and location data. So let's get started. So let's first talk about a new way to create time series data. Recorded queries are a feature that we've recently introduced, and we're really excited about it. They essentially allow you to track anything over time. And what recorded queries are is they're just the data source queries that you're used to making today. And in fact, they're the data source queries against any one of the data sources already available that are evaluated on some interval, and then we store in a time series database where they can be queried again. And we're doing this because we've seen a need to interact with many of our data sources in a more rich way. A lot of our data sources give really good information for what's going on in their respective systems, but only for right now. We see this in particular across our SQL data sources and our software development lifecycle data sources. And so how it works is that you're going to create your query just like how you would normally, and Grafana is going to manage making that query on some interval that you decide. After it gets the result for that, it's going to push the result into anything compatible with the Remote Write API and also the Prometheus Query API. So out of the box, at least Prometheus, Cortex, and Grafana Enterprise Metrics are all supported. And so what does it look like to create and interact with recorded queries? Let's go find out now. So let's say we would like to know on our panel the number of pull requests to the Grafana repo in the last 12 hours. So we want to say pull requests. We want to see that they were created at. And we want to make sure that they're still open because I'm sure some have been closed. And we want to see it on the Grafana repo. Great. And so we don't see any time series data here because this isn't time series data. This is actually just tabular data, where we get a list of all of these data sources that were created. And this is sort of what we see in a lot of our software development lifecycle data sources. And again, additionally, our SQL data sources. But we would sort of like to see what this data looks like over time. Are the number of our PRs growing or shrinking? So what we can do is we can actually record this query. We'll see a new button here, this little clock with an arrow on the query row. And when we click it, we get the options that we need to configure to record it. So we can just give it a name, PRs. And then it can have a description. This is optional. And then we've got an interval and a range. The interval is how often the query is run. For the purposes of this demo, we'll do it every 30 seconds, but there are a bunch of different time ranges that can be run across. And range is how far back we're looking. So to get a similar picture to the query we just did, we want to make sure and say, let's look back 12 hours. Additionally, like we said, this isn't time series data and it's not a single data point. We're recording one data point at a time, so we've got to have some way to make that happen. And in this case, we can just say, aggregate all the things that come back and count them. So let's see what that says. It looks like there are 15 in the last 12 hours. Great, let's start recording this. So what if we want to now see the data that we're recording in our recorded query? Let's get rid of this for tidiness. And we'll see that there's a new button in the query group here called Add Recorded Query. So great, when we click that, we see a list of all available recorded queries in the system, and we can add the one we just created. So if we look at it in the time series view and we look at the last 5 minutes, sure enough, we see a line here that's that's 15, and it's sort of representative of since we started recording it. So that's great. We've recorded a query, and we expect this to change over time. What if we'd actually like to record something about time series data? So let's look at our Honeycomb data source, and let's look at the number of API calls. So this is the count of API calls. This is the last 5 minutes. Let's look at the last hour. It will be a little more interesting. We can see it's kind of trending up, and this is great. We can do all the things we would like to on that. But what if we want to process this data some more and then store the results of that processing? Well, we can actually then lean on Grafana's expression feature to reduce this into a mean of A, and we can actually just record the expression. So we give it a name. Again, it can have a description, interval, and a range. Let's look back over the last hour. Here, we don't have to do any aggregations because that's going to be taken care of by the expressions engine. And we can test that. And we see that 133.26 is the average number of calls in the last hour. And now we can just start recording this, and it's going to march forward every 30 seconds, taking that query and recording it. So great, let's look at a couple of queries that I've recorded ahead of time and have been recording for a little while so we can see this thing in action. So we've got two queries here, one for Grafana issues in the last 24 hours. It's been recorded every hour. And one for open GitHub PRs. It's also been recorded every hour, and they're both looking back a day. So if we add these, the first thing we'll notice is that this isn't super interesting, but that's only because we're looking at the last hour. So if we look at the last 2 days, this becomes much more interesting, or even better if we look back the last maybe 3 days. We can see some interesting trends in our point in time data now. We can see that PRs and issues roughly track each other over time, which is really interesting. And we can also do things like alert or notify on this data now that it's a time series. In addition to sort of being really interesting and exciting because we're getting this data in a whole new way, we're visualizing it with the new time series panel. And in addition to being much more performant than the old one, it gives us more control over the way our data is visualized so we can create more compelling visualizations. So for example, it allows us to change our graph styles. It allows us to change the way the points are displayed so it can be more meaningful. If we would like, we can fill underneath the graphs in different sort of ways with different kinds of opacity or hue. We can see things like this gap here pops out really well when we do this. We can also change our line styles. And we can connect null values. So we see, just like before, we found a gap here, and for whatever reason, we didn't connect that data point. But we know that this is a continuous time series, and if we want this to display that way, we can just say, go ahead and connect that data point. Or if we really want to, we can say only connect data points that happen within some threshold, say an hour. It also gives us control over like how we see the data points. So for really dense data, seeing every data point is not really great for visualization. It becomes too much visually to understand or be meaningful. And Grafana will do its best to decide when to or not to show data points. So as you zoom in, you will eventually see them. Or you can say, always show me the points, never show me the points. Additionally, we've got these new soft min and soft max options. So we've been able to set a min and max so that we can make our views more relevant. So say you normally get 100 PRs at a time, and we've only got 30 now. We can set our max to 100, which is great. But maybe we want to see the data a little closer. So we can set our soft max to maybe 80. And what Grafana will do is it will only by default display 80, but when we get to between 80 and 100, it will start to like expand the graph a little bit. That way you can zoom in and have more meaningful views of what you're seeing in the graph itself without losing the bigger picture relevance. And an additional feature to this that is not great for this data, but that I still want to call out because it's exciting, is that any different time series that you have with different units, Grafana will now allow you to display those different units as the y-axis or scale the y-axis depending on what's there. And so these features together allow you to visualize your time series data in more meaningful ways and create more meaningful, more performant visualizations. So thanks. This has been how to create sort of new time series data and an overview of some of the new features in the time series panel. I'll pass it off now to Jay, who's going to talk about the new Sentry plugin.
Thank you, Travis. And thank you also to Andrew and Mary and the rest of the team here at Grafana Labs who worked really hard to make this feature come to life. I'm super excited to see what users do with the power of recorded queries. I'm Jay, and I'm a product manager here at Grafana Labs. And I'm thrilled to share some work we've been doing in partnership with Sentry.io. Sentry is an error and performance monitoring platform that developers absolutely love. Simply add a small snippet of code to your project, and Sentry captures information about events that you care about, like errors and performance issues. Sentry then intelligently groups those events into issues. So instead of looking at 50,000 errors, you see just the handful of issues in your application causing those errors. It's a super powerful tool. And just like Grafana, Sentry is used by millions of people to make sense out of billions of events happening on hundreds of platforms. Both Sentry.io and Grafana believe that aggregating and correlating all of this information helps you find and fix issues quickly and ship more code. This means happier developers and happier users. So we're super excited to announce the Sentry.io data source plugin for Grafana. We're thrilled to bring Sentry into the Grafana Big Tent so users can view that crucial data from Sentry alongside their other observability data, whether that's more context from additional metrics and logs stored in other systems, or even business data in data warehouses like Snowflake. Let's look at a quick demo. So here's our online hardware storefront, and let's try to buy a few things. We'll get a wrench, and we'll get some nails, and a hammer to drive those nails. And looks like something went wrong. And Sentry's going to pop up and ask us to even fill out a crash report. We won't do that today. So let's switch over to Grafana. So as I mentioned, Sentry will automatically capture those errors, and then it will surface them up into groups called issues. And so you can see here, this dashboard is a high-level overview of the number of errors in this application in our storefront. And while there have been multiple errors, they're really just down to 2 issues. And one really neat out-of-the-box thing that we've done here is deep linking from things like the issue ID into the Sentry interface. So I can click just on this ID here and jump right into Sentry and continue with my usual workflow. But at a high level, we've also now brought all of this information about the issues that are occurring within an application, as well as the statistics across the org, like the number of errors and issues across all of my applications. And we're going to allow you to plot those in Grafana alongside the rest of your data. So let's look at some of that other data. So we all know that the health of the application itself isn't the whole story, right? This software powers our businesses. So let's say that in this case, in my hardware store, I keep track of the number of orders within Snowflake in my data warehouse. So I want to add Snowflake to this dashboard. So I'll go here to my configuration, and I'll look at the new plugins catalog. So the plugins catalog is a great way to see and manage all of the plugins that have been added to your Grafana instance. So first, I'm just looking at the ones that are already installed, but I can switch over and look at all of the plugins available in Grafana's catalog. I can even sort them by downloads and see that people really love pie charts. But I want to add the Snowflake Enterprise plugin to my Grafana instance. So I search for it and it pops up. Now I'll just click install here. And one of the great things that this new catalog has enabled, we didn't speed that up or time shift this in any way. In real time, we've now installed this plugin and it's available to be used. No restarting Grafana or any of that manual effort that we used to have to do. So this plugin is now available. I'll go and configure a data source connection to that plugin. And I have one pre-filled here. So I'll save and test that and make sure it's working. And it is. So let me go back to my dashboard. And I'll just quickly add a panel here. So let's say that we want to keep track of the number of transactions that are occurring, the number of purchases being made. So this is my query here. I'm just getting the time that a transaction occurred and the ID from my Snowflake transactions table within my hardware store schema. I want to look at these. Maybe we want to look at it just a big number of the number of transactions. And let's do this. And I like transparent backgrounds. And we want to count the number of transactions that occurred. And we like to do a background color. And we will leave off the graph. And I like to change the color scheme to blue and purple. All right, great. So now we not only have that rich data coming in from Sentry where we can see any errors and issues, but we've also united that data with other information that's important to the health of this business and the application. We can see over time, maybe the number of errors is or is not impacting the number of purchases that we're seeing. So before I wrap up, I just want to say thank you so much to the Sentry.io team for partnering with us on this. Grafana Labs is absolutely committed to continuing that partnership and maintaining this plugin. And we're really excited to add more features and grow with Sentry.io. I'm also super excited to share with all of you that this plugin is going to be released for free and open source. So all Grafana users are going to be able to connect to Sentry and unite their end-to-end observability workflow. Thanks again for hanging out with me for a few minutes. Next up, you're going to hear from Chris Sachs from Lightstep. He's going to walk you through the great work they did to bring the Lightstep plugin to Grafana. Enjoy the rest of ObservabilityCon. See you on the Q&A.
Thank you, Jay. Hello, my name is Chris Sachs, and I'm a software engineer at Lightstep. Today, I'll be giving you a demo of our metrics data source plugin for Grafana. For those of you unfamiliar, Lightstep is an observability platform combining metrics and traces in order to help you get closer to turning your dashboards into insights. Our product started with ingesting traces exported from a variety of popular frameworks like Zipkin, Jaeger, Datadog, including standards we helped create like OpenTelemetry. And as of February this year, Lightstep has also become a powerful tool to help ingest, display, and analyze metric data as well. Today, I'm going to show you how you can view that metrics data in Grafana and take advantage of powerful features within Lightstep like change intelligence. So let's open up Grafana. Let's say that I'm an on-call engineer who has to investigate a spike in requests. Now, I've set up these two panels with the Lightstep metrics data source. And if I look on the left, it's the rate of all requests. On the right, we have them grouped by operation. Now, the spike on the right here seems to be for just one operation, API get store. Now, being a diligent on-call engineer, I might want to learn more about what's going on. I might want to see if there's a certain customer that might have been, causing this spike. So now I'll click here, add a new panel, and you'll see that the Lightstep metrics data source is selected, and we're given a drop-down with all the metrics that Lightstep has seen so far, and a text box to enter a PromQL query. Now I'll enter this query where I will group the averages by customer to get the rate of requests in those 5-minute buckets. And we'll see that there is a spike again here at around 7:05, but there's one customer who seems to have really been experiencing something. Very curious. So let's go back to my dashboard and continue our investigation. Now, looking at the specific operation here, I'm actually going to want to click on it. And when I click on it, I'm given a data link provided by the metrics data source saying, view what changed in Lightstep. I'll click this button, and it's going to take me right into Lightstep's change intelligence. Change intelligence is a powerful feature combining trace data and metrics data over a baseline and deviation period to identify correlations and provide suggestions to assist your investigation into what could have caused the change. Now, as you'll see, the baseline period is here in purple, while the deviation is marked in blue. And you can grab and drop these and change the selections as you wish. You'll also notice that it's the exact same query we were looking at in Grafana. If I scroll down a little bit, I'll see that it's scoped to this service called Android, but it's also giving us that same kind of anomalous method that we were looking at, API get store. If we are comparing performance across the two, we'll see that the error rate in our baseline was 2.8%, while in our deviation period, it's gone up to 15.8%. Now that's suspicious. I'm going to want to investigate those errors. If I look down a little further, I'll see most likely causes for performance changes, and change intelligence is now providing some attributes on the traces that it's analyzed. If I click this first one, we'll see that this is an attribute on the service store server, and the version 10.8.4898. It looks like that version was present on 100% of the traces in our baseline of 1,000 traces, and only present about 72% of the time in our deviation of 400 traces. Now, this suggests that maybe some of those customers were upgrading to a new version of the store server, and that version had a bug. Now, that bug was generating errors, so I'm going to want to investigate that errors to kind of get a little bit more information around it. If I scroll down a little further, I'll see this section that's labeled traces with error code 429. It looks like 0% of the traces in our baseline had this error, whereas about 12% of traces in our deviation period had this error. Now that looks like a place where I can get some real information for my investigation. If I click in, I see that this is still an attribute on the store server service, and I'm given this button here where I can view sample traces. Clicking in, I'm given the slowest traces with that error code on our service with that operation name. If I click on one of these traces, I'm brought into our trace view where I can now see the spans associated with this trace. If I'm looking for the store server service, I can see the span that's associated with that service. And on the right, I can see the attributes associated with that span. Not only is it an error, it's also on a different version than our baseline. It looks like this version is version 4899. So now I can take this information to the service owner for the store server service and ask them, what happened? What's going on with this version? I can also use this information to go back to customer service so they can reach out to that customer pro wool or any of the other customers who are experiencing that spike and get more information there as well. I hope you enjoyed this demonstration of the power of Lightstep and Grafana together and seeing how change intelligence can help further your investigations. Now I'll hand it off to Alex.
Howdy, everybody. I'm Alex Martin, Director of Professional Services here at Grafana Labs. I'm here to give you a quick run through of the new features that have made their way into the latest versions of Grafana 8. So let's get started. First up is visualization suggestions. Have you ever had a hard time picking which visualization plugin would best represent your data? Well, now with the Suggestions tab in the panel editor, you can see a preview of your data and how it would look like in a variety of panel types. While you're here, let's take a look at the latest time series panel updates. You can now pick a color palette for your line graphs that can be dependent on certain conditions. For example, this palette can color the line based on value. If I switch between max and min values as the condition, the line will change color in response. You can now also have stacked time series graphs. Here is the same ingester client data, but using the stack graph to more easily show the ratio of which gem services are responsible for the clients. The stacking can also be changed to show a fixed 100% ratio instead. Now coming back to this demo dashboard, we've got a set of panels, both logs and metrics. With the latest update, if you hover over a log line, the metrics panels will also show the crosshair and tooltip at the same timestamp. Just make sure to turn that feature on in the dashboard settings. Right now, this only works with logs to metrics panels, meaning hovering over the logs and then showing the crosshair or the tooltip on the metric panel. But the reverse is being worked on, meaning that in the future, you'll be able to hover over a data point and then see the log line highlighted in the panel. Last but not least, the world map panel has been replaced with the new and improved geomap panel. First off, you can now change the base layer for the map to a variety of new options. You can also customize the map markers. You can play around with new settings like size, shape, and color. In the future, we'll be adding the ability to pick icons instead of just simple circles. You can also add a new heat map layer to better visualize clusters of data points and densities. To close out the new enhancements, let's jump to the Explore view. Explore is great for ad hoc queries and visualizing info on the fly. But what if you want to see more than just line graphs? Well, now you can toggle between a variety of visualizations, including all the new updates found in the time series panel. If we go take a look at some logs in the Explore view, previously the volume chart at the top of the log viewer only showed results from the first 1,000 lines. Now with the improved log viewer, the volume chart will show you all of the data points, all the volume in your selected time range. The log lines below still only show 1,000 lines due to performance reasons, but you'll be able to quickly visualize the volume for the entire query range, which is what most people want to see, right? When they're trying to look for how many errors have happened in a certain time range, right? Right now, this only works with Loki, but we'll be enabling this for other data sources soon. For traces, we've got two big updates to show you. First off is the ability to download traces. If you go to the Explore Inspector for traces, you'll be able to download the JSON data. You can then take that JSON data and upload it back into the Inspector viewer for viewing later. This is great if you want to manually share traces, or if the user that needs to go and inspect the trace doesn't have complete access to all the log or trace data sources in Grafana. The second big update in the Traces Explore view is service maps. This node graph at the top allows you to visualize your services architecture and more intuitively understand the flow of your data in your distributed application. You can use this to both visualize your architecture in an impromptu fashion, as well as show the path of a single trace. Well, that's it for this session. We hope you'll enjoy all these new enhancements to Grafana. Up next is my colleague Ida, who will walk you through a bit more on tracing.
Thank you, Alex. My name is Ida, and I would like to talk to you about tracing inside of Grafana. Grafana is usually used as a tool for monitoring, but I will focus on tracing inside of Grafana. I am a member of the Grafana backend engineering team, and currently, two of the things that we are working on is adding context everywhere and implementing OpenTelemetry. Let's start with context everywhere. What does it mean to add context everywhere? We are not referring to everywhere as in every single method. The goal is to be able to propagate context between all the different layers in the backend. For example, all the way from the API layer down to the database layer. I would like to show you our motivation to add more context to Grafana. So in version 8 of Grafana, I configured Grafana to send traces to Jaeger, and we'll be calling an endpoint API search. So in the following video, you can see so I am running Grafana locally in Jaeger as well. I will log into Grafana and trigger the endpoint from the UI. Then I will open Jaeger and search for the Grafana trace. For the API search as trace. And here you can see only 2 spans. So not that much. I will demonstrate exactly the same thing after adding context everywhere into Grafana. So again, logging in and triggering the endpoint from the UI. And afterwards, searching for the API search trace in Jaeger. Yes, it's a much more detailed picture of what's happening in the backend down to the database layer. So side by side, it is visible how much more detailed the spans look after expanding context inside of Grafana from the API layer down to the database layer. Instead of 2 spans, we have now 8 spans. So Grafana will be more traceable than ever. I will shortly talk about the motivation for introducing OpenTelemetry to Grafana. Currently, at Grafana, we are using OpenTracing and Jaeger as a tracing solution. There is a possibility to configure Grafana send traces to Jaeger. What we would like to have in the future is more flexibility for users to configure various distributed tracing systems other than Jaeger for Grafana to export their traces to. OpenTelemetry gives us more flexibility to make it possible. Here are some examples of distributed tracing systems that could be configured with Grafana and OpenTelemetry. So I configured some of those. So here's an example of Grafana sending traces to Tempo with the same API call, API search. Yes. And here the same setup, sending traces to AppDash. There are multiple reasons why we decided to migrate to OpenTelemetry. So OpenTelemetry is considered to be the future of observability. In the future, it should combine metrics, traces, and logs with shared correlation context, connect everything to everything. I hope Grafana users will be happy about the coming changes, and thank you very much for your attention.
Well, thank you so much for joining us today. Hope you guys learned a lot in these presentations that we were giving today. We're going to do a little bit of Q&A. We've got some questions up here. So the first one I see is from Hosea. I hope I'm pronouncing that right. But can I specify the zoom level or the time interval on the graph? I think this was asked during one of the first two presentations. But oh, go ahead.
Oh, sorry, I was going to say, I think this was asked right after the recorded queries during the time series panel. And so I think that this would just be, you can save your time series in any of your graphs. And if you sort of want to change the Y scale zoom factor, you can change that as part of the mins and max that were mentioned.
Awesome. Thank you. All right. A question from Anonymous. Love the new Sentry integration. Looks promising in closing the loop. What data can I visualize using the new Sentry plugin? So I guess what kind of metrics and attributes can you pull from Sentry? Jay, you want to take that one?
Absolutely. So for the initial release today, we support issues and stats, which are two concepts within Sentry. So stats are high-level stats across your whole organization of how many errors and issues have we seen, what are my users doing? And then issues are groupings of sets of errors. So you can get the details about each issue, where they're being detected, who they're impacting, how many events are within those issues. We are exploring adding more capabilities. There's lots more information in Sentry today that's not yet in Grafana. So keep an eye out on some future releases. And if there are specific things in Sentry that you'd like to see in Grafana, please reach out. I'm happy to help prioritize that.
Awesome. Thanks, Jay. We've got a question here from Manish asking, is Grafana ready to use and implement open metrics for metrics collection? I don't know if there's anyone in particular who wants to take that one, but I know that it's been in Prometheus for, it's been partnering with Prometheus since like 2018. And the Grafana agent pulls, it vendors the code from Prometheus, so it should be able to work correctly. But I don't know if anyone else has more information on that. Cool. Hopefully that answers your question. But you should be able to try it out. Alrighty. So another anonymous question. What's the advantage of using Snowflake with Sentry?
Yeah, great question. So in this demo, Snowflake was just an example. The benefit here and the benefit of bringing Sentry into Grafana is that while Sentry does represent some of the health of your application, the overall kind of world that your application lives in and your business is much broader than that. So whether that other data that you Snowflake or it's in another metric store or an APM tool, or that's the value that we're bringing together. So Snowflake was just an example in this case.
Cool. There's a little bit of a spotty hotel connection there, but I think Jay's answer came through well enough. We have a question from Tom, and it's around recorded queries and asking if there'll be a standard for Prometheus exporters in the future. And he loves the idea of recording queries.
Yeah, so for recorded queries, we leverage the Grafana Prometheus data source. So if you have some sort of metric storage that sort of speaks the Prometheus API for queries and can be written to via the remote write API that Prometheus already supports, you should be able to use that. But we sort of make sure, well, we don't make sure, we just offload storing metrics to something that's a time series database, and that should take care of it for you.
Awesome. We've got a question here around traces and logs. Could you explain what is telemetry and what is the difference between traces and logs? You want to
Wow,
take
what
a
a complex question. But from what I understand from the question, it's more about what are traces. So as you could see in my picture, traces show a little bit more data than the logs. You could see how deep I am in the function, and you can have there some additional variables. So that's a short answer. And yeah, telemetry, I think to explain that I would need much more time.
Chris, do you want to take a shot? Give your 5-second pitch on telemetry.
Sure. Telemetry is kind of the general term for all the different types of information that we can get from an application or a service. Logs, traces, metrics are all different types of telemetry.
Awesome.
Thank you. That was great.
No problem.
Awesome. And it looks like the final question we have here is another one from Manish. Have you started using OpenTelemetry for trace collection or plan to use it in the future? I'll throw this one first to Chris. Chris, I don't know, have you guys started using OpenTelemetry standards for tracing?
Yeah, we have. We helped write some of the standards, and we've been able to really utilize and help grow the standards as they've evolved over time. And it's been really powerful to be able to use them in-house as well.
Excellent. And Ida, do you have any thoughts there as well?
Yeah, I mean, in Grafana, we are also working on implementing OpenTelemetry. It's still a work in progress.
Awesome. I think we have time for this one extra question that popped up. What's behind the paywall? Are the recorded queries or Sentry plugin free or behind the paywall? I believe Sentry is open source. Or not? Yeah, that is.
Sentry is free and open source. Go get it today. Yeah.
Go for it. And then the recorded queries?
I believe for recorded queries, we are going to keep that as a paid feature, but we reserve the right to change our mind on that in the future.
Awesome. Alrighty. Got another question that popped up. How do you generate traces for a non-open source application? Do you need to modify the code, or is there another way to implement that? Ida, you want to go first for this one?
I think it doesn't matter. So, I mean, are you adjusting the source code of the non-open source or open source application adding traces? It's the same, I would say. I'm not sure if I'm understanding the question.
Yeah, I guess, Chris, if you have any thoughts, I know I've got something to say, but go ahead.
Yeah, totally. So basically, if you are looking to instrument an application with OpenTelemetry, there are different exporters that you can use, depending on what language your service is running in or your application is running in, that can go and export that data.
Yeah, I believe, for example, anything that's using Java, there's a JVM. There's something you can inject into JVM so that even though it's a closed source application, you can still pull traces from supported frameworks. Alrighty, I think that's all the time we've got. Thank you so much to all the people that asked questions, and thank you so much to our panel. And have a great rest of your Observability Con.
So this is me talking about monitoring remote user workstations with Grafana Cloud and Prometheus. Here's the agenda. We're going to talk about myself and the company I work for. We're going to define the operating environment in which we're trying to solve the problem. We're going to talk about the problem of actually accessing the machines, which is to say the remote machines, the remote nature of the problem, configuring the agent, actually getting the data into Grafana Cloud, and maybe a couple things that I learned along the way. I work for Acrolis. We're a document automation platform in the financial services industry. We primarily power lenders. We have some pretty big customers. Some of the ones I'm allowed to mention include PayPal, Brex, SoFi, Plaid, the other people on this slide. There's a lot more in our brand guidelines with phrases like human in the loop technology, document analysis infrastructure. If those things interest you, I encourage you to reach out via the Contact Us button at acrolis.com or the Start Free Trial button in the top right of the website. We're hiring everywhere in engineering, particularly in front end if you want to work in New York. So I'm Travis Johnson, the Tech Ops Manager at Acrolis. I started my career in IT at a company called support.com, actually, where I mostly fixed printers. I moved on to Linux system administration, where I dropped production databases, moved into DevOps, where I learned Jenkins. I ended up with the SRE title finally, where I made custom internal only and less featureful versions of Jenkins. And just when I finally got around to focusing on reliability as an SRE, I ended up making the decision to build our Tech Ops team. What is Tech Ops? Well, that question is about as straightforward to answer as what is DevOps? So I'll just say it's IT++. And for those of you who are wondering, no, I still don't know how to get your printer to work. Okay, so first let's define our environment and the problem we're setting out to solve. We have nearly 1,000 low-end Linux workstations, and I mean really low-end. The older ones are dual core with a passive heatsink, which we want to start collecting metrics from. These machines live in one of two environments. At home with our employees, where we do not control the network, we can't ensure non-conflicting IPs with other machines, or reach the machines without significant other legwork. Also, we have much more frequent occasional disconnects. One, because they're all on independent networks, but also just home internet is not as reliable as business or data center internet. And then the second environment is inner office with a restricted network, where we can control the IPs and other aspects of the network, or reach machines Prometheus style if we really want to. But the network is restricted. All internet traffic must go through a proxy with no route to public IPs otherwise. So when I originally dived into this problem, all machines were at home, so there was no in-office environment to talk about. This caused me to put a lot of effort into planning rollback strategies, and the labor involved in getting any initial remote management system was going to be pretty monumental. The work from home situation was a direct result of government enforced shutdowns in our region. It was done pretty quickly, and before we had any real team, before my team really existed, to manage it. So there wasn't any remote management solution for these machines either. In designing the solution, I didn't want it to be a one-off, as even a small change in configuration would trigger a redeploy would be pretty disastrous. Because again, it's an enormous amount of work to reach out to 1,000 different users. For simplicity and security, we wanted a push model, particularly since we had experienced the results of Assault 0 Day during the pandemic, as I'm sure some of you may be familiar with. So we went with Ansible. For general remote access, we decided to use Teleport, a beautiful SSH replacement by the folks at Gravitational. If you're not familiar with it, I highly recommend you check it out. It's kind of magic. And because Teleport is an SSH replacement, you can actually just use Ansible over Teleport. So you just get remote Ansible for everything. It's pretty amazing. But then one of our offices opened back up, and I was able to skip the remote access part of the problem, that is to say Teleport, in order to actually just start working more safely on the metrics problem. We re-imaged all the machines in the facility to have an embedded SSH key for use with Ansible. And we got to work. Because the machines were so much closer, we didn't have to plan too far ahead about preventing breakages or whatever, because if we broke a machine, we just walk over and re-image it again. So this is where things get a bit boring, because frankly, Grafana Cloud took most of the hard parts and made it trivial. Resource usage, which would be a concern on these machines, wasn't really a concern. This wasn't so much Grafana Cloud as the Grafana agent, but I still credit the same team there. Ingestion rate configuration, I don't care. I pay per metric, not per push event. Scaling metrics to handle 1,000 hosts might normally be a point of concern, but I think 1,000 is barely a blip on Grafana Cloud's radar. Might be missing a few zeros there before I have any impact. And cardinality bursts due to misconfigurations during testing and setup, I get billed on the 95th percentile. I actually just don't need to think about any of that. So then what is interesting here? Well, for starters, Prometheus makes debugging remote write failures, like a proxy that doesn't have a URL whitelisted, difficult. The discoverability is pretty terrible. I didn't see any logging, and in fact, I found an issue where they said metrics and alert manager was the best way to solve this. You can see this issue here. In fact, finding this was the only way that I was able to debug my problem. When I just suspected it had something to do with the proxy, this is how I discovered that it doesn't log anything for this. Except then, I found a PR where they added logging for some remote write failures, but not all. This was the biggest headache going through this. I'd really love to see it improved, but to be honest, I don't feel like I have a complete picture. I just know that my experience was bad. So now let's talk about my actual agent configuration. This is copy pasted verbatim, no modification from my Ansible repository. And I have two specific suggestions to talk about from here. The first one is set collectors, as opposed to enable collectors or disable collectors. Fighting against or with defaults is not a great experience. And I strongly feel that you should just state be very declarative about what you want rather than trying to modify the defaults. And it'll make it a lot easier, especially to figure out where your metric cardinality is coming from, and if you want to be particularly conservative about how much you're putting up there. The second one is actually that replace instance label flag. Now, it's not strictly necessary because true is actually the default value, but it's so important and I think so valuable that I like to put it there explicitly anyway. With a naive setup, you might end up with every machine labeling itself as localhost. And if you use Prometheus to scrape many node exporters, you'll get their IP addresses. But for this use case, that's not actually particularly useful for me. IP addresses are not reliable, unique distinguishers for these machines. And especially for the ones that are from people's homes. They're just actually definitionally not reliable, unique identifiers. But the host names are, and that configuration value, which again is the default on Grafana agent, changes the instance label to the host name of the machine, which, for anyone who's done Prometheus configuration work before, that's a very common problem that people have to do. And there's ways to do it, but they look a little ugly. And it's kind of annoying that you have to do it every time you set up a new environment. You have to copy paste that same thing again. And it's pretty awesome that it does it for me. So you can see here that I actually use Ansible to change the host name of the machines to match the serial number, or in some cases, the hard drive serial number. The lowest end machines in this infrastructure don't actually expose the machine serial number somehow. It just comes up as 80, so I use the hard drive serial number, which strictly speaking can change, but it's the best that I could do. And then there were a ton of unrelated things that I had to deal with. I mean, the first time that you actually introduce machine management into any infrastructure, you discover all the different ways that everything was drifting. I found bad deep package states, and on a good 10% of the machines, as well as like, just old configurations from previous projects that were never properly removed. Just like, lots of stuff like that is now in a dramatically better state of affairs. And then finally, we started creating custom metrics now that we actually had these Grafana agents running on all these machines, primarily using the text file collector, which is like make cron jobs or other daemons that write the metrics to those files to collect information like human interface metrics, like, the number of key presses, HDD metrics, because unfortunately we do have a fair amount of spinning rust out there. It's the largest source of failures, which we were actually able to properly define now that we had these metrics. And so we can make data-driven decisions around moving everything to solid-state drives instead of just because people don't like it. And Chrome memory usage, which in summary was kind of just all of it, because all these agents did was do things in Chrome. So just to recap, we defined the operating environment, the at-home machines, as well as ones in the office behind a proxy. We talked about the project for accessing the machines remotely, which ended up not blocking the metrics part at all. And again, if you aren't already familiar, I do seriously recommend checking out Teleport. It's an amazing project. We went over my agent configuration and many of the things it took care of for me. And we highlighted the only real pain point of this project, which was debugging the proxy configuration. And that's about it. Again, my name is Travis Johnson. I work at Oculus as a tech ops manager. We're hiring in engineering, everything. Just look on the website. And if you want to reach out to me about this particular talk or anything else in general, or about Oculus or myself, my handle is thisguycodes basically everywhere. I'll also be hanging around to do the Q&A after the fact. Thanks. Looks like we only have one question. So if you didn't have to do this all remote or had more non-pandemic lockdown time to set this up, would you have done anything different? Actually, if I had more non-pandemic time to set this up, I would have solved the remote management problem, which like we're still moving forward with, and is made easier by like all the machines being sort of like in front of us, or half of them. The other half are actually all still people working from home. Because like not having remote management, independent of this project, not having remote management has been pretty hellish in terms of managing these systems, or even just like providing technical support. Like we effectively like can't really deploy any changes to these systems, which thankfully hasn't really been necessary, but definitely would have made some things easier. Managing custom metrics is actually like really easy. Sorry, another question is how hard is it to manage custom metrics? At least the way that I do it, I find it pretty easy. The Prometheus node collector has a file collector. So there's just you give it a directory to look at, and it looks for, I think they're .prom files in that directory. And you literally just like write metrics to files in that directory in the Prometheus exporter format. So like the same format you get when you scrape metrics from your running software. So then I just like make cron jobs that like write out metrics to files, or sometimes it's like you can get fancy and use like a long running daemon that constantly updates it. But like a bash script that writes out Prometheus format to those files is like how I use most of that stuff. We are not currently collecting log data from the machines, but we do plan to. There are the sort of like compliance and security requirements around that are more strict for our environment, given the nature of what these agents are working on. So we have to be a lot more careful about where we send that information. The current plan is actually to use Loki in Grafana Cloud to manage that for us, because of all the same things that it makes super easy. Yeah, there's some extra steps I have to go through with my CISO and our legal team to to make sure that we dot our T's and dot our I's and cross our T's there. Maybe that's about it. We do have more time for questions, but I think that's about it. It's a pleasure being able to talk. I tried to wear the same shirt, but I can't remember if I know it was a Purple Go shirt. Yeah, I buy these from Women Who Go, for those who are wondering. Is it only Prometheus data? So Prometheus is like how we're exporting the metrics from the machine. But we are writing our own metrics to files that Prometheus then, remote writes up to Grafana Cloud. So Prometheus is kind of just the transport. It's not the metric type. It's just the method that we're using to ship the data. But it's all Prometheus style metrics, if that's the question. Yes. Okay. All right. It was a pleasure being able to talk. And I was happy to stick around and answer your questions. Thanks.